हो, चालेल. होईल ते चालू थोड्या वेळानं. 10 मिनिटाचं काम आहे फक्त फक्त जावं नंतर मी फ्री जाऊ.
स्कॉलरशिप स्कॉलरशिप पाहिजे ना.
हो.
माझं काम आहे का
नाही.
जेवण नाही काही नाही. जेवण म्हणजे कशी हलकाही नाही
हम्म,
त्या काय असं नाही का
हम्म.
म्हणजे कामाला बसला
हा.
तिथं झोप काढत
हा, हा. नाही नाही मग त्याला हलकाय पाहिजे.
हलकाही पाहिजे ना.
त्याला इनर्शिया नको जास्त. देतो मी पैसे राहू दे. 2 चाय एक पाणी बॉटल.
मला हलकाय नसतो
हा.
3 वेळा मारवले आलो तो
नाही ना
किती करत
ते त्याचं काम आहे बे ते तर बाबू आबूचं काम आहे बे ना. मी देतो त्याला हलकाय पाहिजे.
Samir sir,
त्याला इनर्शिया नको जास्त.
I have made you host.
देतो मी पैसे राहू दे.
Please mute the others also.
पाणी बॉटल. मला हलकाय नसतो. मारवले आलो ते नाही ना
Samir sir, please mute the others.
काम आहे बे त्याचं बाबू आबूचं काम आहे बे ना. आता काय म्हणतील पण आता काय आजकाल
Please mute the others.
कुठल्या कामासाठी ठीक आहे काय चालू काय रोज उद्या होतील
स्वीट मध्ये नाही राहिलं तर आपण विसरतोच ना.
घेऊन देतो
हा.
चांगला आहे चांगला आहे चांगला
हा.
आहे
हा. हा.
यार म्हणलं ना तो म्हणलं तू आता म्हणलं तो पटली आहे काय आपली विचार नाही म्हणलं
हा.
आपली तर शिक म्हणलो त्याला विचार म्हणलो हे गोष्ट कशी करायची ते गोष्ट करायची. बरोबर आहे हा?
ना त्याच्या ट्रेनिंग असेल ना ट्रेनिंग पाठवायचं नाही का?
ते अनुभवी आहे ना का म्हटलं तो शिकला तर काही नवीन गोष्टी शिकायला भेटत नाही.
बंद करा म्हणून मला जाण्याचं चालू आहे.
Hello. Video on. Hello. आवाज ना आवाज येत आहे ना
Yes, ma'am.
Total.
करते ma'am. आवाज
मॅडम
Hello.
2 मिनिट थांबा.
बर.
येत आहे आवाज येत आहे.
ओके. चालू करू. कसं आहे?
बॅनर आहे काही तसे हा बॅनर
इथे पाठी.
तुमच्याकडे सेव्ह असेल तर तिकडे दिसत नाही कसं ते
Summary, ma'am, is there any issues, technical issues are there?
Hello. Shall I start? Hello, ma'am.
Yes, ma'am. Yes, ma'am. Yes, please.
Okay. So, good morning to all respected guests, faculty members, and dear students. Welcome to the third technical session of International Conference on Green Innovations in Chemistry, Physics, Mathematics, and Computer Science, organized by Sidvi Foundation in collaboration with Semana Vidyava Van Vikas Prashikshan Mandal, Gadchiroli, by Gram Gita Mahavidyalaya, Chimur. I am Dr. Pranali Tembhurne, and it is my pleasure to be anchor for these sessions. We are gathered here today to explore the cutting-edge research and innovations in the field of physics. In these sessions, our invited speaker is Dr. Vijay Paude sir. He is not joining for this time. He will join after some time. So this session we will continue by the participants' presentations. So for these sessions, our chairperson is Dr. Erpude sir. Sir, are you joined?
Madam.
Okay. So Dr. Erpude sir received his PhD in physics from RTM Nagpur University in 2014 and is currently serving as assistant professor in Department of Physics at Nevzabai Hitkarni College, Brahmapuri. With over 10 years of teaching experience at the UG and PG level, his research interests include luminescence, long-lasting phosphorus, and nanoferrites. He has published 89 Scopus Index Journal papers, 4 books and 3 books, chapter with elsewhere, and holds 9 patents and design. Now, he is recognized among the world's top 2% scientists by Stanford University in 2024 in and 25. Dr. Erpude sir has guided 2 PhD students and 4 are pursuing PhD under his supervisions. He has completed a minor research project and received a Best Poster and Oral Presentation Award at the conference. Sir also contributed to the global scientific community as a reviewer for the reputed journal published by elsewhere Springer, Ville, Taylors and Francis and ACE. Welcome, sir. Now, our second guest is co-person is the Dr. Amol Nande, sir. Sir, are you there?
Yes, ma'am, how are
Hello.
you?
Okay.
Yeah, yeah.
Now, Dr. Nande, sir, has a now he is the assistant professor. Sir is the assistant professor of Ballard Shah College and in his academic qualification, he has completed 2 degrees of PhD. First degree from the Department of Physics and Astronomy from University of Canterbury, Christchurch, New Zealand. And his second PhD degree is from Department of Physics, Rashtra Sant Tukaroji Maharaj, Nagpur University. Sir also did the postdoctorate at IIT Guwahati. Sir published 53 research articles in international and national journal. Sir also published the 7 books with national and international publishers, and 15 book chapters are published in Springer, elsewhere, and Ville. Sir published 2 national patents with the Government of India. Sir also awarded with the Motherson Fellowship for doctorate by New Zealand. He is a Junior Research Fellowship at IIT Bombay and awarded by Junior Research Fellowship through National Eligibility Test. Sir is an executive member of India Associated of Physics Teachers Vidarbha body. So, sir, welcome, sir, in this conference. Sir. Now, we are going to start our sessions, and I hand over these sessions to our chairperson and co-chairpersons. So, all the best, all the participants for this session.
Thank you very much, madam. Good morning,
Thank you,
good
madam.
morning, everyone to present here. I, Dr. Atul Erpude, feel deeply honored to serve as the chairperson for this technical session 3 paper presentation in the International Conference on Green Innovation in Chemistry, Physics, Mathematics, and Computer Science, organized by Sidvi Foundation, Visakhapatnam, Andhra Pradesh, in collaboration with Semanna Vidya Van Vikas Precision Mandal, Gadchulleri, Gram Gita Mahavidyalaya Chimur, District Chandrapur, Maharashtra. I am also delighted to share that Dr. Amol Nande sir, Assistant Professor, Guru Nanak College of Science, Ballard Shah, is serving as the co-chairperson for this technical session. In this session, a total 22 participants will present their valuable research contribution. This platform truly brings together brilliant mind and offers an opportunity to exchange innovative ideas in the field of science and technology. Now, let us move ahead with the scheduled paper presentation. Before we begin, I would like to kindly remind all presentation of to a few important guidelines. Each presentation will be allotted 5 minutes for their presentation, and after each presentation, there will be 2 minutes for a question and answer session. Presenters are requested to strictly adhere to the allotted time so that all 70 papers can be accounted smoothly. I take great pleasure in inviting our first presenter, Dr. Ashish Sende, to present their research work on the topic thermoacoustic study in a ternary liquid mixture of ethanol with climatic at different temperatures. Ashish Sende is ready.
I think Ashish Sende is not there.
I think Prashant Bhendarkar sir is ready, I think. I've seen his name in the list. Yes. I invite Prashant Bhendarkar to present their research work.
Yes, sir. Yes, sir. I'm going to present my research.
Okay. You have to present your work.
Yes, sir. One minute, sir. Sir, is my screen visible?
Yes, sir, your screen is visible.
Okay, thank you. Good morning, sir. Good morning, all of you. Myself, Prashant Bhendarkar from Nagpur University. I am working as a research scholar at the Dhote Bandhu Science College, Gundia, whereas as well as I am assistant professor at Bhavbhuti Mahavidyalaya, Amgaon, which belongs to RDMN Nagpur University. To my research supervisor name is Dr. D.S. Chaudhary from Dhote Bandhu Science College itself. I am going to present my paper which discusses about the impact of annealing temperature onto CO3O4 which is a metal oxide towards a supercapacitor application. First, so as we know, in modern days, humanity is facing lots of challenges regarding the global warming and climate change. Actually, we have various methods to prepare to manufacture energy. But there are very few methods through which we can store energy and use it at a very small span of time. One of such method is the supercapacitors. And supercapacitors have overwhelming advantages when it comes to storing energy and use it in a very small span of a time, because they have a higher power density than batteries and sufficiently good energy density, and they also have very good long life cycle, and they are environment friendly. So now there can be many materials that can be used to prepare electrode materials for a supercapacitor, such as graphene or conducting polymers or so and so. But among all these options, metal oxides stand out as environment friendly and economically viable options. So in our work, we have prepared one of such metal oxides, that is CO3O4 cobalt oxide. And, we have prepared this material because we have prepared metal oxides because metal oxides have multiple oxidation states and they show excellent electrical potency to be used in supercapacitor applications. So in synthesis process, we have used cobalt nitride as a basis material and cobalt nitride as a basis material. We dissolved it into distilled water and then solution of sodium hydroxide and urea was prepared and then added, and that cobalt nitrate was added to it dropwise while stirring it. Then the resulting solution transferred to autoclave for hydrothermal reaction at 150 degrees Celsius for 12 hours. The synthesized cobalt oxide then annealed at the 350, 450 and 550 degrees Celsius respectively. This is the process. This is the diagram that depicts how we synthesized our material. Characterization. So after having prepared our material, we did XID studies on it using the radiation using the radiation with wavelength of 0.154 nanometers over the 2 theta range from 20 degree to 90 degree. Particularly speaking about the sample at annual at 350 degree, it showed a distinct peaks at 19.02 degrees, 31.3 and 36 degrees, corresponding to 111, 220 and 311 planes. These planes are really very well cohesion with the JCPDS card number 742120 for CO3O4, which confirms the formation of our compound CO3O4. After that, we observed that the XRD pattern that we observed for 450 degree has a very high intensity. It has a very high intensity, which shows a better crystallinity for 450 degree Celsius sample. The sample which is aired annulled at 450 degrees Celsius showed sharp diffraction peaks. Short sharp intensity peaks, which means the crystallinity of the sample has improved at 450 degrees Celsius after having annulled it at 450 degrees Celsius. So after having done the XID, we did FSM. As you can see here, this diagram shows both XID pattern and as well as same. So we did FSM of all three samples, that is 350, 450, and 550, using the scale bar of 300 nanometer to 500 nanometer, and we observed that as the annealing temperature, that is air annealing temperature, rises from 350 to 550 degrees Celsius, the particle size gradually increases. This probably attributed to the fact that with rising temperature, the mobility of the atomic mobility may get improved, and because of that, we obtained a larger particle size as the time passes. This moderate increase in the particle size may have enhanced the diffusion of the charges across the grain boundaries, which would benefit us when it comes to supercapacitor applications. So these are the XID pattern and the same that we have obtained. After having done the XID and SEM and confirmed about the formation of the compound and the structure and the morphology of the compound, we did the cyclic voltammetry. These are the results of cyclic voltammetry. As can be observed from the image, CV curves recorded at a changing scan rate values from 5 millivolt per second within a voltage window of 0.0 to 0.6 volt versus AgCl. The obtained CV curve display quasi-rectangular shape as can be seen from this image. This prominent redox peaks indicates the capacitive behavior primarily controlled by the pseudo capacitance. According to the paper cited by Mende, nanoscale sizes of the developed electrode material when the electrode material is in nanoscale size, the pseudo capacitive behavior improves, and both pseudo capacitance and electric double layer capacitance plays a role. Conclusion: in this work, we have prepared the cobalt CO3O4 electrode material and then air annealed at 350, 450, and 550 degrees Celsius. We confirmed the production of intended compound using XRD. Further, we did FECM to confirm the particle size rises with the rising in annealing temperature. After performing cyclic voltammetry, we come to conclusion that sample annealed at 450 degrees Celsius showed a better pseudocapacitive and redox behavior. Thank you, sir.
Thank you for your presentation. And Director sir.
Yes.
I hope if anyone has question, ask us. Prashant sir, what are the advantages of hydrothermal method over other synthesis method?
The hydrothermal method is a very cheap method, and the intended nano-sized particles can be obtained using it.
What are the applications of this capacitor, supercapacitor?
As I mentioned in the first slide, that supercapacitor have excellent power density and sufficiently good battery energy density. So if you want to use a single pulse, that is a huge chunk of energy in a very small span of time, electrical energy, you can get it from the supercapacitors. As well, it can store a lot of energy. I mean, it's a better energy density, so it can store energy as well.
In a FECM image, you have shown that the temperature is increasing. The particle size is also increasing. Why this happen?
Sir, as I have mentioned, that atomic mobility might have increased because of the higher temperatures, and thus particle size might have increased. That's what we guess.
Thank you. If anyone have questions, then ask him. No. Thank you very much for your presentation.
Yes, sir.
Now the next presentation is Asim Kumar Biswa.
Okay, thank you, everybody. I am starting my presentation. 1 minute. Sir, is my screen visible?
Yes, yes, your screen is visible.
Okay. Good morning, everybody. I am Asim Kumar Biswas, Assistant Professor in Physics, Department of Physics, Navadip Bidyashagar College, West Bengal, India. Today, I will be talking about the solar cell consisting of cuprous oxide and the considering the different back contact effect on the solar cell performance. My outline of the presentation will cover from introduction to references. In introduction, I will tell briefly about the need and evaluation of solar cell. Nowadays, global energy demand is growing tremendously due to increased population, rapid industrialization, and the widespread use of digital technologies in every aspect of our daily lives. Primarily, this energy comes from fossil fuels like coal, gas, oil, and natural gas. Combustion of these fossil fuels ejaculates huge amount of carbon dioxide gas in our environment, which causes air pollution. And these shortcomings of fossil fuels compel scientists um, to find out alternative source of energy. In this situation, solar cell can overcome this limitation because it is an renewable and sustainable source of energy. Moreover, it does not induce any pollution in environment. Initially, silicon was the most abundant material for making solar cells. But in the case of thin film technology, semiconductor metal oxides have become fundamental resource materials for manufacturing thin film solar cells. A lot of theoretical and experimental studies have been done on the thin film solar cells by various researchers since last few decades. In this study,
your slides is not moving.
okay, the main objectives of my work is to identify the appropriate back contact material and also the effect of different operating temperature at which the device give best results. And finally, we have find out the best calculated values of the device parameters like short circuit current density, open circuit voltage, and fill factor, and lastly, efficiency of the solar cell. The proposed solar cell are given here, and corresponding energy band diagram has been shown here. This is the front contact and fluent of tin oxide, and the window layer is the N-type titanium dioxide, and cuprous oxide has been used as the absorber layer of this device, and a nickel metal has been used as a back contact of this device. And this is a simulation based work, and for simulation of the solar cell, we have used here SCAPS simulation software. There exists several number of numerical simulation software like AMPS, SCAPS, and Aperture. Among those, we have used SCAPS only software. This is a one-dimensional simulation software developed by Mark Barzelman, Honorary Professor, Department of Physics, Department of Electronics and Information System at the University of Ghent, Belgium. This software basically works by solving the Poisson's equation along with continuity equation for electron and holes. And these softwares allows solar cell made up to 7 semiconductor layers with specified parameters, separate entities for interfaces parameters, and 2 additional layers for front and back contacts. And user can set the properties of the material used in the solar cell before simulation.
Slides are not moving.
Chat?
Slides are not moving. Only front slide is shown.
Moving is this? This time moving? Slide moving?
No.
Okay.
Continue your presentations. Don't.
This time moving slide? After simulation, we have result in the output panel of this software. This is the current density have been calculated for different back contacts, and this is the pictorial view of the short circuit current density with absorber layer thickness for different back contacts, and it is observed from the graph that when the back contact of work function above 5 and 6, then the short circuit density of the solar cell is significantly improved. And in the case of open circuit voltage, it is observed from this figure that open circuit voltage is significantly higher for the nickel back contact because its work function is larger. And then we have also calculated the fill factor of the device with the help of this software. And since this is the product of current and voltage at maximum power point and divided by open circuit product of open circuit voltage and short circuit current density, hence open circuit voltage also increases when the back contact work function increase. And finally, the efficiency of the solar cell has also been calculated. In this case, efficiency have increased for the back contact of nickel of work function 5.22. And then we have also examined the effect of temperature on the device performance, device characteristic, because temperature directly influence the performance of the solar cell. And besides band gap of the material and carrier constituents mobility, all these parameters significantly influenced by the operating temperature. And hence here we have controlled the operating temperature from 270 to 390 to observe the effect of temperature on the cell characteristics. It is observed from the simulated results that current density increases, but open circuit voltage, fill factor, and power conversion efficiency decreases for solar cell when the temperature increases from lower value to higher value. Since the increase in temperature raises charge carriers and reduces band gap of the semiconducting material, hence cell parameter shows such behavior. The parameter open circuit voltage strongly depends on the temperature via the reverse saturation current, and then when the temperature increases, then reverse saturation current increases, resulting the lower values of open circuit voltage of the device. And besides, increase in temperature promotes lattice vibration, which obstruct the transportation of free charge carriers. And finally, results the low value of efficiency obtained from the device. And the last section, we have also mentioned here the entire scenario of the current voltage characteristic for the device. And this is the current voltage characteristic for defined back contacts. And the calculated value we have mentioned in this table, it is observed from this table that when the back contact material, nickel and gold has been used as a back contact, then the values of the output parameters like short circuit current density, open circuit voltage, fill factor, and efficiency significantly higher. In my concluding remarks, we mentioned that simulation results show that short circuit current density, open circuit voltage, fill factor, and power conversion efficiency are significantly influenced by the back contact metals and operating temperature. Moreover, current voltage characteristics of this cell improve while metal of nickel of work function 5.22 electron volt used as a back contact. The calculated best values of short circuit current density, open circuit voltage, fill factor, and power conversion efficiency at operating temperature 300 Kelvin and at nickel back contact are 11.358 millimeter per centimeter square, and open circuit voltage is 1.17 voltage, and fill factor 84%, and efficiency 11.33%. And this work may be helpful for the researcher working in the field of photovoltaics. Thank you. That's all my presentation.
Thank you very much, sir. Very good presentation. If anyone have questions, ask it.
Hello, sir.
Why you have choose this copper oxide and tiered thin films for the making of this solar cells material?
Sir, it is theoretical or simulation works. It can be manufactured, but we have used reference in this. In that case, they theoretically observed the various values like short circuit current to open circuit voltage for using copper materials in the device, and hence we use one parameter like back contact parameter and the effect of back contact parameter we have used here. That can be manufactured or experimentally can be tested, but here only theoretically tested, simulatically.
Thank you very much, sir, for your presentation. Now, next participant, I invite Sumit Masakhetri to present their research work on the synthesis and characterization of T/3 plus DOE, SR3Al26 phosphor via weight chemical method for down conversion applications. Mr. Sumit Masakhetri, please present your
Yes, sir.
work.
Yes, sir.
So myself, Sumit Mashakhetri, research scholar at NH College, Brahmapuri, and under the guidance of Dr. A.N. Erpude, I am presenting today's topic synthesis and characterizations of dy dope SR3Al2O6 phosphor by weight chemical method for downcut application. In my presentation, I contain that introduction, synthesis method, characterizations, result, conclusion, and the possible application. Here, the introductions of the luminescence. Luminescence is the cold light emission from the other source of energy which can take place from the normal and lower temperature. Their full phosphor in solid state lighting specifically for the white light emitting diode has increasing due to superior energy efficiency, longer lifetime, environment friendly, etc. When it excited by the blue or ultraviolet LED is crucial for achieving high color radiating and energy efficient light solution across the diverse application from household lighting and to the display technology. This is the experiment. The experiment of the material SR3Al2O6 dy3 plus synthesized by weight chemical method. All the materials we use are analytical reagent, and this process occur 550 degrees Celsius. The resultant powder characterized by XRD, PL, and SEM. This is the synthesis diagram of the phosphor. Now the characteristics. First, XRD, I done the SR3Al2O6. That XRD pattern will match with the standard PDF card number 9015878. And this is the crystal structure of SR3Al2O6. This is the excitation spectra of my sample SR3Al2O6 dy3 plus. When the emissions wavelength is monitoring at 486 nanometer, the strongest excitation peak observed at 3150 nanometer due to 6H 15 by 2, 6P 7 by 2 transitions. Now the another emission spectra of SR3Al2O6 dy3 plus. Under the excitations at 351 nanometer, two bands located that 486 nanometer and 578 nanometer can be observed due to this transition of dy3 plus. And this is the CIE coordinate diagram of my sample SR3Al2O6. The measured coordinate of SR3Al26 were found to be in the range of 486 nanometer, that X and Y coordinate, and 78 nanometer, that 0.635, this and 0.363, making it suitable use in warm LED or red enhanced light LED for improving the quality. This is the surface morphology of my sample. The particle size I vary from 1 to 10 microns. Means that no significant changes in morphology were observed, increasing the concentration dy3 plus concentration, that indicating doping process drastically after the surface characteristics of phosphor material. And the concluding part, while the study of SR3Al2O6 dy3 plus phosphor demonstrates significant potential applications of LED, further research is needed to fully explore its capability and optimize its performance. Future studies should be focused on investigating of the optimal doping concentration of dy3 plus ion in SR3Al2O6 matrix. The emission intensity and color output of the phosphor are highly dependent on dy3 plus doping level, and optimum these parameters could be enhanced the phosphor enhancing the performance in LED devices. These are the concluding part of my phosphor sample, and these are the references I use. Thank you.
Presentation. If anyone have questions, ask me. Younger sir.
So, how can you say that your application of this phosphor can be used for warm light?
Sir, I got from the spectra that excitation spectra of my sample and the emission spectra. From this, I calculate the CIE color coordinate diagram. From that, I can say that samples with the LED LED light making application.
But CI coordinate just refer that whether it is in uh, which color it replicates, means which color it shows,
Okay,
or that warm lighting, cold lighting, or other application. You have to calculate one more parameter called color condensing
color.
temperature, CCT value.
Okay, sir.
Okay, then you can
Okay, sir.
confirm that.
Yes, sir. Yes, sir.
That's all, I guess.
But the next presentation is H.A. Wahane. She present their research work on the topic illustration on physical properties of nickel ferrite nanoparticles using Solgel atto combustion techniques. Arpana Vahan is there. She is ready.
भारी चम्मच है
I think she is not there.
I have seen the next presentation is Ashish Adkane. Ashish sir, hello, are you here? My voice?
Yes, sir. I'm.
Okay. Please.
Sir, hello.
Yes, madam.
Sir, I am there.
Okay.
Sir, give me a minute.
Yes, okay.
Sir, is my screen audible?
Yes, madam.
Your voice is audible, the screen is not visible.
Sir,
Your voice is audible, but screen is not.
my voice is audible, my screen is not audible. Okay, sir. So give me a minute. Sir, can I give after 5 minutes?
I guess so.
Okay.
Atul sir, can we move for another one and then come
Yes.
back to Aparna?
Ashish Adkane sir is ready. Ashish sir?
Okay,
Yes,
then
sir.
Okay. Give your presentation, sir.
Okay, sir. So my name is Ashish Adakne. I am a research student under the. Hello, sir.
yeah, you are audible and your screen is also visible.
Okay, sir. So I'm Ashish Adakne, research student under the guidance of Dr. Nitesh Chambarkar, Vidya Vikas Art Science and Commerce College, Samudrapur. My research paper topic title is Review on Recent Advancements in Ferrite Materials Application in Optoelectronic Devices and Green Energies. So the picture presents the father of ferrites in 1930 in Tokyo Institute of Technology. Takeshi Takai, also known as the father of ferrites, in collaboration with Yogoro Kato, synthesized the first ferrites compounds. Mainly these compounds are the zinc ferrites, which was later TDK companies also commercialized the product. The background of this research is the magnetic materials are generally not recently discovered. It was used by ancient humans around 2500 years. Now, magnetic materials are classified into various types such as diamagnetic, paramagnetic, ferromagnetic, and ferrimagnetic. There are some other types also, such as the antiferromagnetic and antiferromagnets. My main focus of this paper is to aim on the ferrites. Ferrites are nothing but just the metal oxide constitutes of iron oxides with other metals such as the zinc, copper, and nickel. There, the picture shows the classification of the ferrites. The classification of ferrites based on the magnetic fields, they are classified into two types: soft ferrite and hard ferrites. And on the basis of their structure, they are classified as the spinel ferrite, hexagonal ferrite, garnet ferrite, orthoferrite, etc. The research paper generally aim to study the synthesis, characterize optical and magnetic properties by doping various constituents in spinel ferrites. The spinel ferrite general formula is MFE2O4. Here, M stands for the divalent metals such as the cobalt, zinc, manganese, copper, etc. The study shows that by doping some of the divalent metals, their characterization, optical properties or photoelectric properties, magnetic properties can be enhanced. The figure shows the structure of the spinel ferrite MFE4 such that the gold site represent the tetrahedral and the red side shows the octahedral sites. These are the A and B sides. So the one is divalent, other is the trivalent. Other is the trivalent metal. The spinel ferrite can be synthesized by the following processes. Such methods are co-precipitation, salt gel atto-combustion, hydrothermal, microimmersion, and solid-state reaction. The most commonly used methods, or I have studied the common methods, are co-precipitation, salt gel, and salt gel atto-combustion. The advantages of this synthesis are, first of all, salt gel atto-combustion can produce pure crystalline nanoparticles, preserve the homogeneity phase of crystal, and fine size of nanoparticles. This method can be approaches after the salt gel. Second method is hydrothermal, can produces nanocrystalline ferrites, guide spinal structure without. This requires a high temperature. Results and conclusions. So generally, I have studied for the optoelectronics and green energy synthesis only two types of the characterizations. In research paper, I have studied more characterizations, but in here slides, I have to tell about the two characterizations, mainly XRD, and the second one is the UV visible spectrum. So first characterization was XRD. XRD is done to the identify the crystalline structure of the ferrites. Most of the data shows that the doping into ferrites by the other divalent metal does not deform the crystalline structure of the ferrites if their concentration is as required. The second research or second test, that is the UVVs. It confirms that by doping the spinel ferrites, the band gap ranges from the 1 electron to 4 electron volt, which confirm that they can be act as the semiconductors, or they have potential for the optical devices and catalysis. There are some applications of spinel ferrites, such as these optoelectronic devices, as this study shows that they can have the optical properties and their band gaps are between 1 to 4 electron volt. They can be used as optical devices, other optoelectronic devices. It involves radiation blocking also. Example, there are nickel ferrite along with cobalt substitution used in LEDs. Example 3. Mixed ferrites such as the cobalt, zinc, cadmium ferrites have properties. They're mostly used as a solar cell or green energy devices, such as they act as the hydrogen or hydrophoto cell. Hydrophoto cells is the future of the green energy. Now, there are some advantages of this spinel ferrites. The advantages are mainly environmental. They are green materials, magnetic recovery. They can recover the magnetic resistance, enables stability, cost and mostly available. Futuristic approaches in studies of these ferrites are energy storage devices such as the magnetic storage devices, SSD, etc. High frequency devices such as radars, antennas, transmitters, catalysts, and solar. Biomedicals such as magnetic hypothermia. Environmental, they can remove the heavy metal, the removal process of the water treatment process. There are some differences used in the study. Thank you, sir. Thank you, sir.
Thank you, Ashish sir.
Thank you, sir.
If anyone does have any question, please ask. Also, sir, any question?
No, sir. Very good presentation.
Hello.
We move toward the next presentation. PG Vahane. Vahane, madam. Are you ready?
Yes, sir, I'm ready.
Okay.
Hello, sir.
Madam, please
Hello. Hello.
give your presentation.
Yes, sir.
Ashish sir, please on screen, on-share your
Hello, sir.
screen.
Erpude, sir.
Yes.
Hello.
Madam.
Sir, Powder sir is joining. So first we will start our invited talk, sir. Then we will continue our session.
Yes. Okay. Okay, madam.
Okay.
Okay, no issue. Yeah.
Vahane, madam, you have give your talk after Powder sir talk.
Okay, sir. Okay, sir.
So now our invited speaker, Dr. Vijay Pavde sir is joining. So we'll start our he's the invited talk. So first I introduce him. Dr. Vijay Pavde sir is the assistant professor in the Department of Applied Physics at the Lakshmi Narayan Innovations Technology University, Nagpur. His research focus on rare earth dot oxide material and their applications in LEDs, solar cell devices, and photocatalysis process. He has published 51 research papers in referred international peer-reviewed journals and act as a reviewer for journal published by elsewhere Springers, Willett, Taylor and Francis, RSC and ACS. He has contributed 12 books chapters on different themes like nanomaterial synthesis, characterizations and their applications in energy conversions and storage devices. He is an author of book titled Phosphor for Energy Saving and a Conversion Technology and Optical Properties of Phosphate and a Pyrophosphate. He has edited 8 books on nanomaterials for green energy, spectroscopy of lanthanide doped oxide materials, multifunctional nanostructure metals oxide for energy harvesting and storage devices. Sir also worked as a member on examinations and evaluations committee panel assigned by University of South Africa, University of Free State, etc. Currently, 1 PhD student awarded under his guidance and 2 are registered for PhD and 1 is submitted. Thank you very much, sir. Sir, now you can proceed.
Thank you, madam, for very nice introductions of my work and me also. I'm audible? Yes?
Yes, sir.
Yes, sir.
Okay. So, thank you. Can I share my presentation?
Yes, sir. Yes.
Okay. So, I hope the presentation are visible to everyone. Yes. Screen is visible? Hello?
Yes, sir.
Yes, sir.
And I'm also audible, I hope. Okay.
Yes, sir.
Okay. So first of all, I thanks to organizing committee for inviting me for this conference and also for the management and principal for providing an opportunity to introduce my work that I am working on material science. Okay. So dear friend, first I would like to introduce about the work that I am going to present here. So all of you know that from past few decades, the research in development of new and advanced optical materials gain more importance in emerging field of science and engineering. And because material is the backbone and basic building block of technology, and without materials it is not possible to develop new and emergent efficient devices for variety of applications. And we know that properties of materials can be tuned with respect to their shape and size, because there are two factors that deals with the properties of nanostructure material. Basically for nanostructure material, because nanostructure materials is a smart class of materials, and these properties of these nanostructure materials can be vary based on two factors like high surface area to volume ratio, as well as their band gap and confinement effect. And band gap is the physical concept that deals with the energy band of the materials, as well as to understand the basic properties and phenomena. The knowledge of chemistry and physics are also important. Beside this, there is also important of some computer knowledge that we can simulate the property with the help of some mathematical modeling. So knowledge of physics, chemistry, computer science, and mathematics are important to understand and to simulate the properties of nanostructure materials. Okay, so the nanostructure material that deals with the optical property, and this optical property that deals with the bulk and nanostructure materials are nothing but the non-linear optical property, because advanced nanostructure luminescence materials find promising scope in fluorescence, bioimaging, drug delivery, biosensor, photothermal therapy, solar cell, LEDs, as well as anti-counterfeiting and security applications like fingerprint detection, etc. And this presentation focuses on the development of lanthanide dope upconversion phosphor for fingerprint detection and high security application. Okay, so the outline of this talk that contains the introduction to luminescence phosphor and related process, different optical processes that held in rare earth of phosphor, and the importance of phonon energy in a conversion process, synthesis approach for the fabrication of nano-sized luminescent materials, and also discuss some materials that exhibit some efficient luminescence, upconversion luminescence properties when doped with suitable rare earth ion, and the potential applications along with their conclusion. So the introduction to luminescence, this phosphor and related optical processes, these are the fundamentals, okay, that deals with the materials absorption emission process. So luminescence that we define is the emission of light by the materials when some external energy or radiation get incident on it, rather than the heat. Okay, though this phenomena is totally different from the black body radiation. Here material can emit the light in certain wavelength when it absorbs the light of one wavelength. And there are different type of luminescence that studied in past few decades, that is photoluminescence, cathodoluminescence, electroluminescence, chemical luminescence, and others. Okay, all this depends on the excitation source. So here basically I'm going to focus on photoluminescence, that is the luminescence get observed by incidence of light radiation, and radiation is nothing but a stream of photon. Okay, and materials that can exhibit the luminescence property are known as phosphor. Okay, and this phosphor basically the class of inorganic materials that looks white in appearance, but when we dope adds an impurity rare earth element that can exhibit the luminescence properties. So here rare earth ion play an important role that exhibit the optical property in different spectral range, including the visible and NIR and IR range. Okay, when it doped with suitable host lattice like aluminates, silicates, fluoride, tungstate, vanadate, oxide, all these are the well-known inorganic host materials that get studied in last few decades, and these materials can find promising scope in optical devices as well as other application that I mentioned in discussed in previous PowerPoint presentations. Okay, so here I'm not going in detail here. So these are the rare earth element lanthanide ions that used in luminescence studies, and here cerium, samarium, europium, and terbium. These are the lanthanide materials that shows the optical property in visible spectral range, along with dysprosium also, and the listed in the last one, holmium, erbium, thallium, ytterbium. These are the impurity or lanthanide element that used in the analysis of upconversion mechanism in some host lattices. So these listed, there are lanthanide element, holmium, erbium, thallium, and ytterbium are mostly used in upconversion study. So here we discuss the different optical process in rarer dose phosphor that can exhibit the downshifting mechanism, down conversion mechanism, and up conversion mechanism. So here this mechanism of light absorption and emission that's shown by respective energy level diagram. So in case of downshifting, the materials absorb the photon of one wavelength and it can emit the two photons. That is the downshifting mechanism. For example, it can absorb the light in one wavelength like UV, and it can emit the light in visible spectral range. Okay, because atom here can absorb the light, goes to the higher excited state, and later it come back to the ground state with emission of radiation in the stream of photon. Okay, in case of down conversion, there is the probability of photon that can emit the light in respective energy level that's shown by the red mark here, red arrow, in respect to one energy level, other energy levels. That is the down conversion mechanism. But the up conversion mechanism is totally different than downshifting and down conversion mechanism, because in case of up conversion mechanism, two or more low energy photon that are converted into single high energy photons. Single high energy photons is photon that get absorbed or get converted into one single energy photon that have the low high energy as compared to the incident photon. So this upconversion mechanism, specifically you find in only 3 to 4 lanthanide element that shown in previous slide, like holmium, erbium, thallium, and ytterbium. So here this upconversion mechanism in some host lattices, this mechanism can be well explained based on their excitation and absorption mechanism. So here the mechanism of upconversion luminescence, first we discuss based on excited state absorption. So in case of excited state absorption, the materials or atom, those are in the ground state, absorb
और अब डाउन
the
ऐसे हो जाएगा
energy in 980 nanometers, mean near IR range or IR range, that it absorb, and this absorb atom goes to the excited state E2. So first state, that arrow shown here from ground state to E1, this is the ground state absorption. Later on, atom in the excited state E1 again absorb the energy, that is called as excited state absorption. Later it reached to the energy level E2, that is the upper excited state, and from this upper excited state, atom remain come back to the ground state. This mechanism is called as excited state absorption, because energy level E1 and E2 is being utilized for the emission of light in visible spectral range. That we can say that here the photon in NIR range or IR range up to 980 nanometers get converted into visible photon. Okay. Another mechanism, that energy transfer up conversion mechanism. This energy transfer up conversion mechanism that we can understand in case of different lanthanide pairs, because for energy transfer we must have two different lanthanide pairs. Okay, so example is also given here. YbEr is one combination pair, HOYb is another pair, TMYb is another ion pair that utilized to understand the energy transfer upconversion mechanism. So energy transfer process that is called as ETU can be well represented in these equations, ET1 type and ET2 type. So here in first diagram we can understand here the ion 1 that's shown here in the ground state. Okay, ion 1 can occupy the E1 levels. Again, this can transfer to the ground state of ion 2. Okay, and this ground state of ion 1, this one ground state of ion 1, again is shown by the reverse arrow. This is the non-radiative transition, means radiation losses in the form of heat, and this excited ion of this ion 2 of this again goes to the E2 levels. Okay, goes to the E2 level. Later on it comes back to the ground state. And further, in case of E22, this energy transfer 2 case is simply shown by this diagram. Here both ET1 and ET1 mechanism shown here, that how the ion 1 can transfer their energy to ion 2, and also how it can emit the light that's represented in this diagram. Again, ET2 process is clearly shown here, that ion 1 can absorb the ground state absorptions. Again, this non-radiative transition is there. The excited atom goes to this energy state E2 of ion 2, that is lanthanide ion 2. And again here the absorbed atom goes to the E1, and here the excited atom come back to the ground state with the emission of visible upconversion. Okay, so this ET2 process, that ET2 process is also clearly represented by these equations. And again, ET1 process also have the probability that ground state absorptions can transfer their energy from E1 to E1 state of this ion 2, and again it's shown by excited absorption, that excited atom in the state E1 absorb energy and it come back to the ground state. So this energy transfer upconversion process in lanthanide pair, when it doped with tungstate as well as some fluoride crystals, can exhibit intense emission in visible spectral range. Another one is the cooperative energy transfer. So this type of process requires the involvement of energy transfer process, in 3 ion, because cooperative energy transfer that represented in this diagram, that shown by ion 1 lanthanide, ion 1, ion 2 and ion 3. That example is also given. If we have the 3 different lanthanide, that is TM doped with Yb and Er, all these are the combinations that we can understand in case of cooperative energy transfer between the lanthanide ion. So ion 1 here have the strong ground state absorptions, and again this absorbed atom goes to the E1 state, E1 to the ion excited state of ion 2, and again this excited atom again goes to this E1 of ion 3, and again there is strong absorptions from this ion 3 also, and the emission that we shown here by the green mark. So in this case we have the absorption in ion 1 and ion 2. In ion 2 we get the emission in visible spectral range. So this cooperative energy transfer that we observed in case of 3 lanthanide pair, that will form a ladder-like energy structure. So any process in case of lanthanide pair or triplet lanthanide pair, that we can understand this upconversion mechanism with the help of this ladder-like energy level structure. Okay. Another and most important, that is relaxation energy transfer mechanism. So cross relaxation mechanism can be well understood based on this diagram that's shown here. The ion 1 goes to this even level, and again even level atom goes to the E2, and again it come back to the E1, and again it goes to the ground state of ion. So this type of cross relaxation mechanism get exist in case of different lanthanide pairs, and this type of cross relaxation mechanism in upconversion can exhibit the tunable optical property. Means optical property can be tuned if the material in the nano size. So already we discussed about the nanostructure material can exhibit the tunable optical property based on their band gap and confinement effect. And we know that confined particles always have the more energy. Okay. Another photon avalanche is also another mechanism that exists in case of a conversion process. So here, this photon avalanche mechanism can also consist of this cross relaxation mechanism that's shown by the pink dotted line, this cross relaxation mechanism, as well as ground state absorption and ground state absorption and excited state absorption mechanism can also get exist here, and the probability of the emissions can also be well understand that it located in between E2 and ground state of the ion 2 that's shown by the green arrow. So all these mechanism get exist in case of upconversion. And here the development of rare earth activated upconversion phosphor host gain more importance in wide range of application, including solid state lasers, optical data storage, color display and illumination, solar energy harvesting, that we can use this kind of spectral converter material that we call is spectral converter material, because the upconversion phosphor can convert the near infrared or IR photon into visible photon. And because of these advantages, we can use in solar energy harvesting, because currently the silicon solar cell have some restrictions that it can capture only UV and near UV part of the solar spectrum for the energy conversion. So it cannot capture the visible and IR part of the solar radiations for the energy conversion. So utilizations of these upconversion particles in solar energy devices, solar cell, we can enhance the light conversion efficiency, as well as it can be used in super resolution microscopy. It can be used as a biosensors, biological labeling, optical thermometry, and photothermal therapy also. Besides this, in security, it can be used in anti-counterfeiting and fingerprint detections. So based on this non-linear optical property and unique behaviors of these materials, these upconversion phosphor can exhibit anti-Stokes optical features. Anti-Stokes means that it can exhibit the scattered light of higher wavelength in respect of the incident light. So therefore they have the wide scope in science and engineering field. And here among the different host materials that discussed in previous slide, like aluminate, borate, tungsten, etc., these fluoride based materials can find promising scope and exhibit intense upconversion emission when it doped with lanthanide ion. And nowadays this fluoride compound become very much suitable due to their characteristic features, that the low phonon energy that deals with the fluoride as compared to aluminate. That phonon energy is important because based on the phonon energy, we can find the promising application like biocompatibility of the materials in cell imaging, as well as we can achieve the high efficient upconversion emission based on their low phonon energy, because energy transfer gate exists that can emit the light of high efficient wavelength as well as high transmittance, because fluoride itself a very whitish color, stable chemical and physical property. And also for the synthesis of this fluoride host materials, it required low temperature because of this some issue that is with the other materials. So it does not require high cost, high temperature processing techniques for the synthesis of fluoride based host materials. And here, from past few decades, because of these characteristic features and requirement of low temperature synthesis as well as stable physical and chemical property, these fluorides widely researched as an effective luminescence matrix among the many class of host materials that invented and studied from last few decades in luminescence. Okay, so now here I am going to discuss the importance of phonon energy in upconversion process. Already we discussed this mechanism of photon interaction in condensed matter physics as well as in solid state physics. So in material physics also, this phonon energy play an important role, because phonon energy is crucial in case of upconversion process, because it facilitates the energy transfer that needed to proceed the high efficient upconversion emissions, where materials that can emit the high energy photon that it absorbs, means the photon one or more photon of low energy that converted into high energy photon that it absorbed by the materials. So phonon acts as an energy sink that enables the absorption of energy from multiple low energy photon and subsequently transfer to rear earth ion, that we can achieve the emission of single or high energy photon. That is the basic mechanism that deals with the low phonon energy host, so that we can achieve the phonon of high energy with utilization of two or more low energy photons. Okay, and here the materials with low phonon energy like fluoride are often preferred because they are allow more efficient energy transfer with minimum energy loss, and this type of energy loss that associated with the energy transfer process that deals with the non-radiative losses, because non-radiative transition that associated with the heat loss. Okay, so this non-radiative decay that leading to high efficient upconversion luminescence, so we can avoid the losses that associated with the non-radiative decay during the upconversion luminescence process. Again, energy mismatch is also one important parameter here, because energy difference between absorbed and emitted photons is often large, because phonon are quantized vibration of the crystal lattice. Quantized means the atom get resting between different equispace energy levels, because band gap, if we consider the band gap in case of bulk materials and nanostructure materials, the bulk material have the continuous band, but in case of nanostructure material, they can form the quantized and equispace energy levels. So materials can locate anywhere between the energy levels, so that's why they can exhibit the tunable property, and they can exhibit the quantized vibration of the crystal lattice, and hence it can provide the energy to bridge this energy gap. So it means that the lanthanide doping in case of fluoride host material can form a ladder-like energy level structure. Ladder-like energy level structures where this type of upconversion mechanism get exist. And this photon-assisted energy transfer is nothing but that involve the phonon assisted energy transfer mechanism, where this phonon assist in exciting the rear earth ion to allow for the absorption of multiple low energy photon. So that's why the phonon energy is very much important in upconversion study. And if we compare the phonon energy of oxide tungstate and fluoride host, fluoride always have the low phonon energy as compared to the oxide, and because of the low phonon energy we can achieve the high efficient upconversion emission in case of fluoride crystals. Okay, so here the well-known upconversion hosts that shown here that have the low phonon energy that studied in last few decades, that is the sodium yttrium fluoride is the well-known high efficient upconversion host materials that studied from last few decades, as well as to achieve the high efficient upconversion emissions with the doping of lanthanide ion. Ytterbium Yb3 plus is the well-known sensitizer material, sensitizer ion, because of their high absorption capability that important in case of upconversion process. So absorptions range of this Yb is high as compared to other sensitizers. So based on their numerous energy level structure, this is a more compatible and mostly used sensitizer ion with other lanthanide ion like thallium, holmium, and erbium. So energy transfer process that exists between this Yb3 plus, Tm3 plus, Yb3 plus, HO3 plus, and Yb3 plus, erbium 3 plus exhibit high efficient upconversion emissions. And here these sodium yttrium fluoride nanoparticles that dope with the different lanthanide pair that shown here, erbium Yb, Tm Yb, Ho Yb, it emit intense visible upconversion emission, and hence because of this low phonon energy and intense upconversion emissions in this type of lanthanide pair, this type of upconversion host with high efficient emission applicable in fluorescent imaging, drug delivery, as well as optical thermometry, as well as other host materials like sodium, gadolinium, yttrium fluorides, so lanthanum fluoride are the among the most well-known host materials, and there are several reports that available and the effective upconversion luminescence as well as their promising applications in biomedical as well as other related field of engineering. So now here I'm going to discuss the synthesis process that applicable for the fabrication of lanthanide dope upconversion host materials. Okay, so in material science or in case of nanomaterial synthesis, basically there are two approaches that important to synthesize the nanostructure materials. So these two approach that deals with the top down and bottom up approach. So top down means conversion of large to small, that is called as physical approach, and for this conversion of large to small in case of top down we can apply the grinding, crushing, ball milling, etc. That we can apply some mechanical approach that we can convert the larger size into smaller size. So the basic drawbacks of this technique is that it requires some costly equipment as well as the material lost is also there because material gets stuck on the surface of crusher, etc. So here one more drawback that deals with this technique is that there exists a surface roughness on the surface of the nanostructure materials due to continuous grinding, crushing, etc. And presence of these surface imperfections can create some defects. So this is not an ideal technique for the fabrication of defect-free nanostructure material, and we know that presence of defect can affect the corresponding properties and applications of the materials. Okay, another approach that also considered as defect-free approach for the synthesis of nanostructure materials called as bottom-up approach, that we can convert the atom into molecular scale. Atom can convert into molecular scale into nanoscale. So this is the conversion of small from molecular scale to large scale, that is in the nanoscale. So approach is small to large, that we can convert the molecules in liquid phase into solid phase. So this is the chemical approach, and here the cost of this approach, that we can utilize the different material synthesis technique. In case of bottom-up approach, they are all the low-cost technique, and there is wastage of materials also very less. And one advantage, that we can create the defect-free nanostructure materials by using this bottom-up approach. So in case of bottom-up approach, various chemical synthesis method like sol gel, precipitation method, hydrothermal, sorvothermal technique, ultrasound sonication technique, chemical vapor deposition technique, all these are the methods that use, as well as one more is there, micro emulsion techniques, okay, reverse misses technique, etc. All these are the chemical approach that use for the fabrication of nanostructure materials. So here now I am going to report some results that we synthesize in our laboratory with the help of this different chemical approach, that is bottom-up approach for the synthesis of upconversion nanoluminescent materials. So here the first host that we I am going to present here, that is the holmium and ytterbium doped SR2F7 nanocrystals, that is synthesized by wet chemical method. So the individual metal precursors like strontium nitrate, yttrium nitrate, and lanthanum nitrates that we used here, okay, that we dissolve it in distilled waters. After that, we stir it to mix it properly. We get transparent solution. Later on, we can heat all this solution of this metal nitrates and in a one beaker that will heat it at 80 degrees centigrade with continuous stirring and heating. So later on we can add drop wise ammonium fluoride for the formation of white precipitations. After continuous heating and stirring at 80 degree until the complete evaporation and formation of white precipitation, materials then collected, solution then collected in sample holders, that we can centrifuge it in distilled water so that we can separate the water and precipitations with the help of this centrifugation technique. Later on, we can collect the settled precipitation at the bottom of this test tube. Further, it can dry it for 150 degrees for few minutes. Okay, so we get this type of white precipitations. After, we can anneal it so that we can remove some toxic gases that get exist inside the materials, so we can get the pure homogeneous product. Okay, after anneal at 400 degrees centigrade, we get this white precipitations. Okay, and the final white product, when we monitor under a 980 nanometer laser excitation source, it can emit this type of light. So this is the upconversion emissions under 980 nanometer light illuminations. Okay, these are the experimental steps that involve in the synthesis of lanthanide dope, these SR2YF7 nanocrystals. So these are the XRD patterns. So from this XRD pattern that clearly indicate the formation of nanophase of the luminescent materials, because a line broadening in the diffraction peak gives some tentative idea about the formation of nanophase of the luminescent materials, and this observed nanophase of the luminescent materials get well matched with the standard GCPTS file that's shown here, and there is no additional impurity phase get exists in the diffraction pattern. And this diffraction technique is the non-destructive testing of material characterization that is important to analyze the phase purity of the materials. Another we can characterize the materials by this ACM index technique to know the morphology as well as the compositions, the atomic weight percent of the materials that get exist in the compositions. So the observed composition can be analyzed with the IDAS that attach with the SEM graph. Okay, from the selected area we can analyze the presence of yttrium, strontium and fluoride phase in the host materials along with their composition in percentage. Okay, now upconversion luminescence that we can monitor here under 980 nanometer laser excitations. 980 nanometer laser excitation. This excitation source is widely used in upconversion measurement that equipped with fluorescence spectrophotometers. So here the upconversion luminescence spectra for the strontium yttrium fluoride material that dope with 1 mole percent HO and 5 mole percent of 5B as well as 5 mole percent of HO and 5 mole percent of YB. The concentration of the sensitizer YB3 plus ion is constant. We can vary only the concentration of HO, and here we can obtain this visible spectral band in case of this strontium yttrium fluoride host, and we get the intense spectral band at 540 nanometer as well as 645 and 653 nanometers in green and red region of the spectrum. So here for the lowest concentration of this HO and HO plus doping, we get this intense information in visible spectral range. Okay, further we have choose the lanthanide in place of yttrium. So Sr2La57 that also doped with YB3 plus and HO3 plus phosphor that has been synthesized by co-precipitation technique. So here we used EDTA Na2 plus distilled water as a surfactant that will control the particle size, because surfactants is important that we can control the particle size of the nanostructure materials, because basically the nanostructure materials that are synthesized by different technique have the variation in particle size, but to control the particle size of the synthesized nanostructure materials there is need to add some surfactant during the reaction process. So here these are the steps that involve in the synthesis of this strontium lanthanide fluoride by precipitation technique. So all these metal ingredient will dissolve in distilled water. Again, in the third step, we can add some dilute nitric acid having the pH that will maintain at 2 and stir for 20 minutes. After formation of clear solutions, we can add the dropwise NH4F for the formation of precipitation. So at this step, so we can also apply the 60-minute stirring, and later on the formation of white precipitation, we can apply the washing and centrifugation process in ethanol and water. So after centrifugation process, the material gets settled at the bottom of this test tube. Again, we can collect it and dry it for 70 degrees centigrade. So as synthesized nanoparticles again get annealed at 800 degrees centigrade. So during this annealing process, the particle size that we achieve during as synthesized state get vary, that clearly observed in X-ray diffraction pattern. So this annealed powder further get monitor under 980 nanometer laser excitation. It can exhibit the intense green upconversion emission, and later on we can apply it for the fingerprint detections. Okay, so there are some characterization that also be important to know the phase purity of the materials. So these are the X-ray diffraction pattern of the synthesized and annealed materials at 850 degrees centigrade. So all these get clearly well indexed and match with standard GCPTS file. The crystallized size that we can calculate here for as synthesized materials that we can get the 6 nanometer of the crystallized average. These are the average crystallized size, and we anneal at 50 degrees centigrade. There is the increase in crystallized size. So in case of as synthesized, the line broadening that clearly exhibit the formation of nanophase, and after annealing at 850 degrees centigrade, the particle size of the materials get increased. So we get this type of pattern, the sharp pattern that basically deals with the formation of pure crystalline phase of the materials. Again, this we can characterize the materials by TM. Again, here we can calculate the particle size that's shown here inside this graph, that small circular particles that can clearly observed under the 20 nanometers resolution scale. And here are the particles that have the maximum particles that located in between 6 to 6.5 nanometers. Okay. Again, here the upconversion emission spectra that we can observe for the 5 mole percent of YB and X mole percent of HO. So here we have vary the concentration of HO with respect to sensitizer YB3 plus ion. So concentration of HO in varying in between 0.51, 1.5 and 2 mole percent. So basically for the high efficient upconversion process, there is need to dope the lanthanide in higher amounts. So highly doped lanthanide are preferred to achieve the high efficient upconversion process. And here the concentration versus intensity graph for this emission spectra that located at 480 nanometers, 435 nanometers, 540 nanometers are shown here. Okay, so from this, again, we have measured the upconversion spectra for the annealed strontium lanthanide fluoride that dope with holmium and ytterbium ion. So here the 5 mole percent of YB and X mole percent of HO can exhibit the intense spectral band at 540 nanometers. Again, here we can separate the band of the actual spectra that observed for annealed sample. We can also observe the spectra that cannot clearly observed in figure number A that located at 750 nanometers. But if we can enlarge the spectra, then the nature of the spectra look like this. Again here the 540 to spectra that here we can vary the YB plus concentration here. YB concentration can be vary. Again, if we can vary the YB 3 plus ion concentration with respect to constant HO plus concentration that fixed at 1.5 mole percent, similar spectra can be observed as those appeared for the YB and HO that's shown in figure A here. Okay, so 542 nanometer and 653 nanometer that in red region get also achieved at the same position. So in case of this 750 nanometer spectra, if we can further enlarge it in case of varying YB plus concentration, the location of this 750 nanometer peak is also same as those appeared in case of HO3 plus varying concentration. So these are the applications. So this intense upconversion phosphor that dope with 1.5 mole percent of HO and 15 mole percent of viability plus concentrations that monitors in daylight. So figure 8 that exhibit in daylight how this fingerprint looks. But when we sprinkle upconversion phosphor materials on this fingerprint, okay, and later on we can observe or monitor in 980 nanometer laser illumination, it can exhibit this type of fingerprint detections under high efficient grip green upconversion emissions. Okay, so these are the advantage. So this type of 980 nanometers excited upconversion host material can find promising scope in fingerprint detection. Again, there are some other hosts that we can synthesize this CaF2 based upconversion nanoparticle. So CaF2 is the well-known calcium fluoride upconversion phosphor host that studied from the last few decades in luminescence research. So here we have developed the control shape and size CaF2 nanostructure materials by using solvothermal approach. The detailed schematic steps, experimental steps that shown here for the preparation of CaF2 upconversion host by using solvothermal approach. Solvothermal and hydrothermal approach is a well-known bottom-up approach, as well as we can see this chemical approach for the synthesis of control shape and size nanostructure materials. So here oleic acid is being used in combination with ethanol and sodium hydroxide. So here oleic acid acts as a well-known surfactant that will help to control the particle size of the nanostructure materials that we can achieve in case of hydrothermal or solvothermal approach. Okay, so here we can form a solution one of this precursor. Again, we can form the solution 2 of the calcium nitride and lanthanum nitride that we can use here along with some distilled water in some few amount. So solution 1 and solution 2 get insert in one beaker and stir for 15 minutes, so it can form a solution 3. Okay, so this solution 3, now that the combination of sodium fluoride along with distilled water, that we can add here solution 1, 2 and 3 in one beaker and again stir for 60 minutes. So combination of solution 1, 2 plus solution 3 that formed by the addition of sodium fluoride along with some distilled water. So all these solution get transferred in one beaker and it stir for 16 minutes. 60 minutes later on, this solution now kept inside this Teflon like autoclave, okay, that set at 160 degree for 24 hours. After the completion of this reaction, solvothermal treatment, the materials that inside this Teflon autoclave get collected and redispersed in cyclohexane, because cyclohexane is used to stable the formation of the nanophase of the materials. So it redispersed in cyclohexane and it's precipitated by adding ethanol and again it's centrifuge. Okay, so again after centrifuge process the precipitation gets settled at the bottom, again it collected dry and again dry powder. We can collect the dry powder and again we can disperse in cyclohexane. So inside this cyclohexane, the dispersed particles of the nanostructure CF2 materials can also exhibit the rate of conversion when we monitor under the 980 nanometer laser excitations. Okay, laser excitation. So these are the emissions that we can achieve from this synthesize upconversion materials under 980 nanometer laser excitation. So application part, basically this also applicable for this fingerprint and antarctic applications. So first here we analyze the materials by using X-ray diffraction technique to understand the phase purity, and here this X-ray diffraction pattern clearly indicates the formation of nanophase that clearly observed in line broadening in diffraction peak, that also well matched with standard JCPTS data. Again, FTIR characterization is also carried out to understand the presence of different type of OH, CH2 stretchings, carbon double bond stretching, asymmetric vibration, symmetric stretching in COO group, etc., as well as the available of CAF stretching that in because of the CF to host matrix. All these stretching, vibration, bending, all are symmetric groups and functional groups of the metal oxygen bonding, etc., are also available in different wave number that assigned here. Okay. In TM analysis, this TM analysis is being carried out to know the particle size of the synthesized nanostructure materials and particle size. So average particle size that we can get here, the 14.96 nanometers. And further, the mark here some of the hexagonal crystals that we can form due to control synthesis of the nanostructure materials in presence of oleic acid. So these particle shapes can be controlled. So hexagonal shape that form here, that clearly observed in TEM image, that observed under 50 nanometer resolutions, and these are the different lattice planes that associated with the nanostructure that mark here. Okay, these are the electron diffractions patterns of this image that we can measure the spacing lattice spacing between the two different planes that we can measure vertically, horizontally, in any directions with the help of image software. That here the spacing is observed 0.3 nanometers and 0.26 nanometer, etc. Okay. And further, these upconversion limitations in CEF2 can also exhibit the intense green emission at 540 nanometers, along with some weak red emission that located at 650, and the mechanism of energy transfer in between HO and YB that's shown in this energy level diagram. This because of the high absorption is of YB, it can absorb the incident light, get transfer the atom at this 7F5/2 level, get transferred to the excited state of HO, from where from the highest state 5s2 that corresponding to 5 F4 state, that we can to ground state 5IH state, we can get the intense green emission, and from 5F5 to 5I8 we can get the red upconversion emission in HO and YB3 plus doping. Okay. And further, this upconversion emissions in this HO of YB and ER can also be investigated here. In case of this YB and ER, we can get the intense upconversion in red region as well as in 540 nanometer that deals with the green upconversion emissions of this erbium. So it means that we can get this two spectral band in visible range under 980 nanometer laser excitations. Again here, this inside picture shows the intense red upconversion emission in case of ER and YB that deals with this spectral energy transfer from YB to ER3 plus ion. Again, we doped CaF2 with 0.5 mole percent of TM along with YB. But in this case, we get this emission in some violet blue regions that are not associated with NIR spectral range, because this emission band that's shown here that deals with TM and YB that illuminate under 980 nanometer laser excitation. So here these are the another spectra that deals with triply doped CEF2. Triply doped means we have doped with erbium, thallium and YB. So during this triple doped, that is iron 1, iron 2 and iron 3, we get this spectra in blue, green as well as in red spectral region because of 3 lanthanide pairs in CEF2. Okay, so these are the application part that we have applied this synthesized phosphor upconversion phosphor host in fingerprint detections under 980 nanometer laser excitation. So these are the fingerprint that we can measure here on different substrate. So here on two different substrate that's shown here in figure A and C, that we can get this type of the intense red emissions during these fingerprint detections. Again, in case of anti-counterfeiting applications, that we can synthesize materials, we can apply here and observe in this written word CAF2, that also marked by the synthesized materials under 980 nanometer. This CAF2 looks like this. Okay, these are the anti-counterfeiting applications. Again, one more applications that I'm going to discuss here, the tunable upconversion emission in YB and HO3 plus lanthanum fluoride upconversion host. This material is also important because these materials here we have synthesized by using reverse micro emulsion reaction technique. This is also new technique that we can utilize, that in case of micro emulsion technique we can form a two phase, one emulsion phase 1, emulsion phase 2. Later on, emulsion phase means oil phase and liquid phase, that's two phase is being formed towards the formation of micelles, that is the smaller size. Micelles means about the molecular level, so formation of micelles that will later grow the formation of nanostructure materials. Further here, cyclohexane as well as some other materials is being used for the formation of micro emulsion of ingredients, micro emulsion 1 and 2. Further we can sonicate it for 15 minutes with the help of ultrasound sonicators. So micro emulsion 1 and 2, when it mix and stir for 20 minutes in a closed Teflon vessels, later on sonicate, the breaking of micro emulsion can be possible by the addition of few amount of methanol, because here we have two phase, oil and liquid phase. Okay, oil and liquid with the help of this cyclohexane and some other surfactant and materials that used in the preparation of materials by using this micro emulsion approach. Further washing and centrifugation process, we get the white precipitation that settle at the bottom of this test tube after drying at 80 degrees centigrade and annealed for 4 hours, that we can get the final product that exhibit this type of intense upconversion emission. The picture are also clearly shown here in the next diagram in case of upconversion study. So these are the X-ray diffraction pattern that we can examine for lanthanum fluoride synthesized by microemulsion approach. That is also well matched with standard JCPDS data. This is also FTR data already. All these functional groups, stretching, vibration that associated with OS, CH2 and metal oxygen are also observed in FTR spectra. These are the TEM images, that the formation of the particle size, average particle size that look out find out to be 63 nanometers, and these are the corresponding upconversion emission spectra of YB and ER, that intense green emission located at 538 and small weak intense emissions in red region also get observed because of the energy transfer from YB to ER. This is also for YB and HO, that we can get the intense green emission at 537 and small weak emission at 640 nanometers. Also this YB and TM, that we can get the emission at 470 nanometer and one strong emission at 800 nanometer. So basically the green blue fluorescent upconversion emission in TM and YB, basically this deals with this NIR light, and because of this NIR light, when we capture the image with the help of some mobile camera, the image looks blue in color. Basically this is not deals with this 474 nanometer, this deals with 800 nanometer NIR light. Okay, So these are the upconversion spectra, measured spectra, and the luminescence outcomes that measure under 5 milliwatt laser excitation source in our laboratory, that we can capture the image that looks for HO and ERYB, that green in color, but in case of TMNYB, it observed in NIR 800 nanometer, but it looks some violet bluish color, that is not deals with the 474 nanometer, etc. Okay, so these are the applications. So here basically we have utilized these materials for the formulation of high security ink, that we can write here the ink with the name of this notation UC, and this is the ink that we can fill inside this glass bottle when we observe it under 980 nanometer laser. So this it can emit the intense green upconversion emission. So these are the applications of this upconversion phosphor materials in anti-counterfeiting, high security ink, as well as in bioimaging application field. Okay. So in conclusion, I would like to note a few points that this tetragonal phase upconversion phosphor materials that is simply achieved by using wet chemical method. This simple and low cost technique that we can fabricate the lanthanide dope upconversion phosphor materials, okay, as well as cubic phase of this strontium lanthanide fluoride can be achieved by using co-precipitation method, where we can use some surfactant, and particle size along with high intense upconversion luminescence can be achieved that find promising scope in fingerprint detection, as well as some CF2 upconversion nanoparticles that is synthesized by solvothermal liquid solution approach with the use of some surfactant with controlled shape and size hexagonal nanostructure particles can be well synthesized, and it find promising scope in anti-counterfeit applications. Again, lanthanum fluoride upconversion phosphor wood that is reported by reverse microemulsion methods using oil and liquid phase that also exhibit the intense green upconversion emission for the promising scope in high security applications. So finally, I would like to conclude that the fluoride being an ideal upconversion host due to their unique and anti-stoke properties that find promising scope in variety of applications, including biomedical as well as in engineering field. So thank you for your kind patience. Now I request to the chairman to open this session for discussion.
Exam form भरने से पहले काय था मैडम बोल रही
Hello. If there is any question, please proceed. If anyone does have any queries or questions, please go ahead. I think audience doesn't have any, but I do like to ask a question that
Yes.
Do you have facility for upconversion or you get it somewhere?
Yes, sir. Yeah, for primary detection of upconversion luminescence, we have fabricate one laser source device
Okay.
that is of 808 nanometers and 980 nanometers. In primary, we can observe in our laboratory. Later on, we can send it for IIT Bombay. Okay.
Okay. So
Because
how long does it take to get result?
result. Sorry, yes, sir. Yes, repeat it.
कितना समय लगता है around?
Sir, around before the process for characterizing the materials from IIT Bombay involve different steps that we have to first book the slot, later on payment, later confirmation that we can send the materials. After 15 days that we can get the results. So near about
That's not bad.
1 minute is required, 1 month is required for all process.
Yeah, but the result was really amazing. I really appreciate that.
Yes.
If you even focus for high blazing action phosphor, you can easily go for it. It was
Yes.
really fascinating.
Yes, yes, yes.
It was a nice presentation. Thank you very much for enlightening us on upconversion phosphor and gas synthesis process.
So anyone
So,
interested to work with my group in my laboratory, that facility is also available here, that you can primarily check it with the help of synthesize material as well as some device that we can fabricate here, as well as we can fabricate one smart spectrophotometer using webcam. With the help of
okay,
laser source, we can with the help of laser source and some software, computer software, we can draw the spectra that exactly match with the those that we can observe from the IIT Bombay also.
that's wonderful.
Yeah.
Actually, then it will be very quite handy
Yes,
that you in future you can have your own spectrophotometer for
that hope
upconversion.
waiting for funding that we can also do that.
Hope for the best. Okay, without any further delay, if no one has any queries, I would like to thank Paude sir for such a wonderful and knowledgeable lecture. I imagine we got many new things to learn today from his experience. And as you said, if someone wants to collaborate, definitely they will join. Thank you very much, sir.
So thank you once again.
Thank you, sir.
Thank you.
All right. So we can resume our
Now we'll continue our
overall
technical.
presentation.
I overhand to Dr. Erpude sir and Dr. Nande sir. Sir, please continue.
Yeah. So we were like going to invite Rohani madam
Yes,
for a
sir.
talk. Is she there?
Yes,
Are
sir.
you there?
Yes, sir.
Yeah. Please. Okay. Okay. Please continue with your talk.
Yes,
As
sir.
we said, you have to present for 5 minutes and 2 minutes will be for posters.
Okay, sir.
Are that okay? Okay. Okay. You can
Uh,
proceed.
a very good afternoon to one and all. I am Arpana Vahane, a research scholar of Postgraduate Department of Physics, Nagpur University, Nagpur, presenting my paper on investigation of physical properties of nickel ferrite nanoparticles using sol gel method autocombustion technique. The outline of this presentation is introduction, synthesis, result and discussion, conclusion, and references used by me. Now, why I am using nanomaterials? The nanoscale is about a billionth of a meter, and things this small can behave quite widely. This unusual physical and chemical characterization come about because there is an increase in surface area compared to volume as particle get smaller, and also because they are subject to quantum effects. This means they can behave in different ways and do not follow the same laws of physics that larger objects do. Now, why the nanotechnology has variety of applications. Few of them are information technology, advanced material and textiles, energy and environment, aerospace, medicine and health, food and agriculture, national security and defenses, transportations, biotechnology, and of course mechanical engineering and robotics. Now, among all the nanomaterials, magnetic nanoferrite particles have generated diverse technology interests because of their potential applications in magnetic fluids, high frequency magnets, magnetic bulk cores, microwave absorbers, and high density data storage. Among these, I had used ferrites, nickel ferrites as my interest. I am having that more interest in that. So nickel ferrites are extensively used in electronic devices because of their large permeability at high frequency, remarkable high electrical resistivity, mechanical hardness, chemical stability, and low cost. Now, I had used sol gel method for the synthesis of nano nickel ferrite materials. In that procedure, I had used two precursors, nickel nitrate and iron nitrate. I had prepared the gel by using this precursor dissolved in distilled water. I had added crystal citric acid in it and stir it for about 70 to 80 degrees Celsius for near about 5 hours. Then I had to adjust the pH level of this gel. I had used ammonia. After that, after getting the gel, I had dried the gel at about 100 degrees Celsius to remove the moisture. For calcination, I heated the gel at 500 to 80 degrees Celsius to get the nanoparticles of nickel ferrite. Now, the result and discussion. For result and discussion, I had done XRD, I had done FTIR and TEM of the given sample. XRD was obtained using Philips PW1710 automatic X-ray diffractometer. FTIR was formed on FTR 8101A spectrometer and electron transmission electron microscopy images were obtained using CM 200 STEM. XRD spectrum. This is the figure shows the XRD spectra of nickel ferrite nanoparticles calcinated at 600 degrees Celsius. The XRD pattern of nickel ferrite shows all the peaks correspond to spinel ferrite space and space structures according to JCPS data. From the bordering of the peak, crystalline size and lattice parameters of the synthesized nickel ferrite was found to be 24.2 nanometer and 8.40 angstrom respectively. Maximum intensity peaks occurred at 2 theta 35.57 degree and assigned to reflection 311 of the spinel ferrite. Nickel ferrite nanoparticles have structural formula Fe3C Ni2C Fe3C consists of tetrahedral site A and octahedral sites B. The nickel ions Ni2C together with half of ion Fe3S occupy B side and remaining half of iron ions reside in A side. Now, the FTIR spectroscopy provides valuable information regarding the nature of the functional group present in the nickel ferrite. The figure shows intensive broadband at 2950 centimeter inverse and less intensive band at 1539 centimeter inverse for nickel ferrite. Are due to the OH interaction through H bonds. The band near 932 centimeter inverse indicates stretching vibrations of antisymmetric NO arising from the nitrate group which is present as residue in the samples. The absorption band U1 and U2 around 667 centimeter inverse and 519 centimeter inverse are attributed to the stretching vibration of tetrahedral and octahedral group complexes of ferrite respectively. Now, TEM figure shows that prepared nanoferrite materials have mostly spherical or irregular morphology. There is evidence of alligation which is common in magnetic nanomaterials due to the dipole-dipole interaction. The contrast and shape suggests the presence of crystalline domains with the aggregated structure. The TEM image confirms the successful synthesis of nanoscale nickel ferrite particles. The particles are predominantly below 20 nanometer in size and form aggregated cultures. From the above discussion, synthesis and result, we can conclude that nanocrystalline nickel material has been successfully synthesized by Sol gel method. The color of gel nickel ferrite is found to be brown. The XRD shows all the corresponding peaks of spinel ferrite space with face-centered cubic crystal structure. FTI spectroscopy confers the formation of nickel ferrite nanoparticles with a spinel structure and the particle size is found to be 20 nanometers. The references used by me are thank you.
All right. The session is open for question now. If anyone does have any questions, please proceed. All right. I would like to ask, what do you mean by spinor structure?
So,
What do you mean by spinor structure compound? You said your nickel ferrites are in spinor are belong to spinor structure compound. So
sir,
what makes
I'm not getting properly.
you
Hello.
said that the nickel structure,
हाँ
the nickel compound nickel ferrites is prepared
हाँ
are
sir.
spinal structure. बराबर है? They have spinal structure.
Yes sir, there are spinal structures.
हाँ, so how can you say that this what is mean by spinal structure? How it is different from regular structure?
So the shape of the material, the atoms situated in the what I can say, the atoms in the material are arranged in such a way that we get a spinal structure. Hello.
But in spinal structure, atoms are arranged in spinal shape or it is at the corner or somewhere like that?
Sir, they are in the proper, sir, means they are arranged in the corners only, but we can assume them in a spinal space.
All right. All right. All right. Any further question? Okay. Okay, Aparna madam, thank you very much.
Okay, thank you, sir.
Is Pragati Katre is there? Pragati Katre. All right. RP Goodpile. RP Goodpile. Vadgure. Vadgure sir is there? Nanda Gauri sir.
Yes, sir, I am here.
I think.
Seeing you
Did
on the
you
screen.
you already delivered or you are going to deliver now?
No, sir, just I am sharing my
Uh,
screen.
okay, okay. Please, sir.
Okay.
This topic is synthesis and multi-phase characterization of early substituted NiCO final ferrite nanoparticle for a high frequency and energy storage application.
Sir, just I am sharing, but there is some technical problem. Once again.
Right one more time, sir. Yeah.
Okay, okay, sir. Actually, there is an internet problem, so just I have connected my mobile hotspot. Sir, am I audible?
Yes. Yeah, you are audible, but
Nandi,
your
sir, am
screen
I
is
audible
not
to you?
visible.
Okay, sir.
Yeah, yeah, you are audible.
Just a minute, sir. Just a minute. Just a minute. Where are those? Okay, sir.
Yeah, now your screen is visible.
Yes, sir. Just a minute. Oh, okay. It is going to open. Sir, is it visible on the screen, my presentation?
No, but your
Nandi,
screen is visible, but your screen is visible, but your
sir, I
presentation
have,
is not.
sir, I have opened my presentation here. Sir, now is
But
it
it is not.
visible?
It is your folder is visible. Your
Sorry,
presentation, does you are having two screen or what?
sir, just
Two
I have
monitor?
shared. I have shared, sir, in the computer. I have shared my presentation. Screen is sharing
Okay.
there.
Try, unshare it
Uh,
and
sir,
try
can
to
I?
share whole screen rather than presentation.
Sir, just
Try
I
to
am.
share whole screen.
Yes, sir.
Stop
Just
sharing one more time.
sorry. Now is it visible on the screen?
No, no. Ah, now it is. Now it is.
Yes, sir. Yes, sir. Okay, okay. Thank you, sir. So
Yeah.
myself, Mr. Nityananda Gauri. I am assistant professor in Department of Physics, Institute of Science, Nagpur, and my research work is about investigation and study of structural, electric, dielectric, and magnetic properties of some ferrite nanoparticles for for technological applications. And my research work is going under the supervision of Dr. Bhausaheb Devmunde from Department of Physics, Vivekananda Art Science College, Chhatrapati Sambhajinagar. So my presentation is about the synthesis and multifacet characterization of ELA3 plus substituted nickel cobalt spinel ferrite nanoparticles for high frequency and high energy storage applications. So the outlines my presentations are about abstract, introduction, material synthesis and characterization, result and discussion, conclusion followed by references. So the polycrystalline lanthanum substituted nickel spinel ferrite nanoparticle, they were synthesized using the sol gel autocombustion methods. The precursors were used nickel nitrates, ferric nitrates, and citric acid as a chelating agent to initiate the reaction. The crystallite size, it ranges from 39.76 nanometer with unsubstituted lanthanum to 23.73 nanometer with the substitution of lanthanum. Yeah, there is a reduction in the lattice parameter from 8.3084 angstrom unit, which confirm the effective incorporation of lanthanum ion into the spinel structure. The spinel structure therefore was characterized by means of XRD, the Fourier transform, FTIR, Raman spectroscopy, and it was further validated by the field emission scanning electron microscopy. So in that case, the materials with the particle size is or equal to 100 nanometers and which responds to the external magnetic field. They are generally called as nanomagnetic materials. They have the high surface area to volume ratio, which exhibits the superparamagnetism and possess unique magnetic properties that differ significantly from the bulk materials. Sorry, 1 minute. Just so in ferrites, so the ferrites is a magnetic materials composed of iron oxide Fe2O3 and other metallic elements such as manganese, zinc, or nickel. The ferrites are ferrimagnetics, meaning they are capable of being magnetized and attracting other magnets, but they do not retain their magnetic field once the external field is removed. The ferrite, they have the several key properties, that is the high magnetic permeability, that is response with the external magnetic field. They have high resistivity, that is low electrical conductivity, low eddy current losses, high saturation. Now the high nickel cobalt ferrite. So nickel cobalt spinel ferrite is the ideal for high frequency and energy storage applications due to its tunable property. Its high resistivity, which minimize the energy loss at the high frequency, while its strong magnetocrystalline anisotropy enable the operations in gigahertz range. So therefore, the structure it can be implemented for high energy storage. Again, it can be implemented for the capacitance and stability, making it superior multifunctional materials. So, so it is the synthesis method. Just the precursors were taken. It is about the solvent formation synthesis method. So we have characterized the form structure by means of X-ray diffraction technique, followed by Fourier transforms, spectroscopy, FTIR, Raman spectroscopy, vibrating sample magnetometer, scanning electron microscopy, that is FECM, and impedance spectroscopy. So it is about the XRD pattern of the structure. Sir, just I have not mentioned my JCP test card number, but the nickel ferrite and the cobalt ferrite structure, spinel structure, were verified with the JCP test card number 460908 and 221086 respectively. So in that case, the peaks they can occur as on the 1 position to 2 position, which confirm the formation of spinel structure. Even in that case, with the addition of lanthanum, With the addition of lanthanum, the lattice parameter is slightly decreases. It means the lanthanum ion, introduction of lanthanum ion in the pure nickel cobalt structure, it incorporate and distort the structure. It is about the FTIR spectroscopy. This FTIR spectroscopy, it can analyze to determine or to detect the functional group present in a crystal structure. So in that case, the red line or the red graph it indicate the lanthanum dope, nickel cobalt ferrite. In that case, the peaks occur around 584.11 centimeter inverse for the octahedral site and 417.42 for octahedral sites. For the for the pure nickel cobalt ferrite, the peaks occur at 58883. So in that case, with the FTIR, just we have confirmed that the functional groups are present there. It is about the Raman spectroscopy. In that case, 5 peaks are there. The stretching peaks, the vibration peaks from the Raman spectroscopy. Just we have confirmed that the said functional groups, they are present there. It is about the FECM. This FECM was used to determine the percentage ratio of the elements present in the said structure. Morphology. The FECM micrograph reveals that the nickel cobalt spinel ferrite nanoparticle, they have the polycrystalline structure with irregular shapes. The particles appear to agglomerate, forming larger cluster rather than being individually dispersed. The grain size distribution. The inset histogram shows the bell-shaped curve for the grain size distribution, which indicate the majority of nanoparticle fall within a specific size range, with the highest frequency occurring around 80 to 100 nanometer. The EDX spectrum confirms the elemental composition of sample, showing the presence of nickel, cobalt, iron, and oxygen. In that case, the table is given at the right. It is about the image flow. So the sample was characterized with VSM vibrating sample magnetometer. So from the look, we can see the saturation magnetization for the pure nickel cobalt, it is 59.81, whereas for the lanthanum doped nickel cobalt ferrite, it is 49.92. So in the red area, it is just a hysteresis loss, that is the magnetic loss. So that magnetic loss is less in that case. Therefore, this lanthanum doped nickel ferrite spinel ferrite nanoparticle, they can be implemented for the high energy storage magnetic materials. For the direct properties. So from this, with the frequency response of the structure, so this lanthanum doped nickel cobalt ferrite, it can be implemented for the high frequency application, since in that case the dielectric loss is less. Both nickel cobalt and lanthanum nickel cobalt ferrite, they exhibit very high dielectric constant at the lower frequency. This is likely due to the Maxwell-Wagner type of the interfacial polarization, which is common phenomena heterogeneous material. Frequency dependence, the dielectric constant and the dielectric loss decreases sharply as the frequency increases. Lanthanum nickel cobalt ferrite shows significantly high dielectric constant and loss compared to the nickel cobalt sample, particularly at lower frequency. This suggests that lanthanum substitution introduces additional interfaces defects which enhance the polarization effect. Both material, they exhibit very low dielectric loss at higher frequency, making them sure for the high frequency applications where energy dissipation due to the polarization is undesirable. So lanthanum substitution in nickel cobalt spinel ferrite successfully achieved via the Soldier autocomp. profoundly influence their structural, magnetic, and dielectric properties. The incorporation of La3 plus ion was conclusively verified by the systematic reduction in both crystallite size and the lattice parameter. The substitution directly softened the magnetic character of the material as evidenced by the decreased coercivity and saturation magnetization. Most significantly, the synthesized nanoparticle exhibit exceptionally low dielectric losses at high frequency, positioning them as excellent candidates for the high frequency microelectronic applications such as filter and antenna substrate. Their enhanced dielectric losses suggest promising utility in the energy storage devices. Therefore, lanthanum doped nickel cobalt nanoferrites emerge as a versatile multifunctional material tailor-made for advanced high both frequency telecommunication and communication. So these are some references. Sir, I think there is a net problem. Just hello.
Hello.
Sir, there is a there is a just net problem, sir. Just I have connected my hotspot. Just
Why?
I have connected my hotspot, so there is a just internet.
No, there is not any net problem. You are audible and your screen is also visible.
Sir, you are audible, but your voice is not clear here. Just I am in the institute, and the internet problem is there. So just I have connected my mobile hotspot.
Okay, it's all right. So am I audible now?
Yes, sir. Yes, sir. Yes, sir. Yes.
So question now the session is open for questions. If does anyone have any questions, please proceed.
Sorry, sir.
Sir, I have one question. Why did you choose lanthanum?
Sir, even in that case, in many literature review, so lanthanum is there, and one more thing there, lanthanum is a weakly paramagnetic materials, and it is the sopan. But however, we can introduce the lanthanum in a magnites or in a spinel structure, so it can alter their crystal structure, and it can undergo super exchange interaction, leading to enhance the magnetic properties. The doping of lanthanum is useful for optimizing the material for the high frequency applications and for the magnetic storage devices. So that basically lanthanum is a soft, weakly paramagnetic material, but it can exchange the, but it can alter the positions. So that's why.
Thank you, sir. Thank you very much.
Okay, sir. Thank you.
Now we will go for second participant, Maldari. Maldari is present, sir. Maldari, sir. Is he here? All right. Maldari, sir, is not here. Shingade? Shingade? Okay, he is also not here. Bokse, sir? YS Bokse? No, he is also not here. Gane? Gane, sir? All right. Murunalini Dhawas, madam? Is she here? Murunalini Dhawas? Murunalini Dhawas. Okay, she is also not here. Parishit Chaudhary, sir? Parishit Chaudhary? All right. Mr. Kokulwar, sir? Kokulwar, sir? All right. Parshuramkar, sir? DM Parshuramkar, sir? Kalyani Atra, madam? Kalyani Atra, madam? Saili Guru? Saili Guru? First of all, anyone can confirm, am I audible or not? Anybody can confirm my voice is audible or not?
Yes, sir. Yes, sir. You are audible, sir.
Okay. That's wonderful. Saili Guru and R.S. Meshram, sir. Hello. I could see few names, but they are not responding. So, madam, should we continue or what? We reach the bottom of the list now.
Sambhurni ma'am, have you sent the updated one now? Program schedule?
Yeah, I received one from Samir sir and Atul sir.
Actually, in the updated one, sir, 25 physics presentations are these.
Yeah, 25 was there. I didn't count, but still there are like now I call for like 50 people.
Oh.
Yeah, I could see Saili, Murnalini, but they are not responding. So what should we do now? Should we conclude or should we wait for some time?
Yes, sir, you can conclude now.
Conclude, no? All right. Okay. So it's been a great honor for me and on behalf of Atul sir to chair this the session. I would like to thank organizer and the college principal, especially Samir sir, to giving us opportunity to chair this session. I also like to thank all the participants who actively present their work, share their ideas. And at last, I would like to thank you, Vijay sir, for their wonderful technical session, which enhance our knowledge. Thank you. Thank you, ma'am. Thank you all.
Thank you, sir.
Okay. Should I leave the chat, ma'am? Leave the call?
Yes, sir. Yes, sir.
Okay. Thank you.
Hello. I would like to extend our sincere gratitude to our esteemed chairperson, Dr. Atul Erpude sir, and our dedicated co-chairperson, Dr. Amol Nande sir. Your guidance and support have been helpful in making this session a definite success. Our heartfelt thanks also go to our distinguished invited guest, Dr. Vijay Paude sir. It is the gracing for us, your presence today. Your valuable insights and contributions have greatly enriched our discussions and inspired all of us. We would like to thank all the participants for your active engagement and insightful questions, which truly made these sessions interactive and challenging. Finally, on behalf of everyone involved, thank you all for being here and for your support. We hope you found this session as valuable as we did. Thank you once again. Next sessions on mathematics, we are going to start. So I hand over to the Nagesh sir.
हाँ आज नहीं है ना आज अब छुट्टी आहे मी तर आता माझं लेक्चर आहे इथे
एकदम बढ़िया आ रहा है ले रे बा दोन कदे दोन जमा पाकड आपण दोन आहे कधी पाहिजे हमारे उद्योग
हेलो आवाज येऊन राहिला
Yes, sir.
okay so next we are going to start आवाज कमी माझा एक मिनिट याचं बोलू
तारीख करून टाका
चला बरं hello
Yes.
yes okay so next we are going to start our technical session 4. Good afternoon, respected guests, faculty members, and dear students. Welcome to the fourth and final technical session of this conference for the subject mathematics. With this immense pleasure, I welcome you all to this technical session of the International Conference on Green Innovations in Chemistry, Physics, Mathematics, and Computer Science, ICGICPMCs 2025. Today we are gathered here to witness the exchange of innovative ideas, groundbreaking research, and thought-provoking discussions that truly embody the spirit of this conference. This international conference is not just an academic gathering, it is a movement toward the sustainable science and technology. The focus is on the green innovations, innovations that protect our environment, conserve resources, and create solutions in harmony with mathematics. We are honored to have distinguished researchers, academicians, industry experts, and young scholars from across the globe joining us. On behalf of the organizing committee, I extend a warm welcome to each one of you. Now it is my privilege to introduce the chairperson for this technical session, Dr. Ramnaresh Sisodia sir, who is currently working as an associate professor and head department of mathematics, Sardar Patel Mahavidyalaya, Chandrapur, since 2012. He did his PhD in the year 2011 from St. John College, Agra. Sir has 18 years of teaching experience and research experience. His area of specialization includes fluid dynamics, physiological fluid dynamics, integral equations, and operational research. He has published more than 25 research papers in various reputed international and national journals. He also published 34 books in various national level publications. Alongside, we are privileged to have our co-chairperson, Mr. Ankush Ramtege sir, Head and Assistant Professor, Jnanesh Mahavidyalaya, Navargaon. He is specialized in mathematical modeling in space science and has published several research articles in reputed journals. He has also authored multiple textbooks aligned with the Gondwana University, Gadchiroli. In addition to his academic work, Sir is actively involved in web development, having successfully designed and developed educational websites for several prestigious institutions. His contributions are widely recognized and appreciated by the teaching fraternity. We thank both of them for accepting our invitation to guide and moderate this session. In this session, we have invited talk by our Honorable Dr. G.D. Kedar sir, who is also my guru at my post-graduation. it's my pleasure to introduce Honorable Dr. G.D. Kedar, sir. Sir is currently head and professor at Postgraduate Teaching Department of Mathematics, Rashtrasant Tukdoji Maharaj, Nagpur University, Nagpur. His research area is solid mechanics and operational research. Sir has 32 years of teaching and research experience. Sir has supervised 7 students for their doctoral research. Sir is the member of various boards. Some of them are Indian Society of Theoretical and Applied Mechanics, the Indian Science Congress Association, member of Board of Studies, RTM University, Nagpur. Sir has organized various national and international level workshops, seminar, and conferences. Sir has completed 3 research projects. Sir has chaired 14 national and international technical sessions. Sir has delivered 21 national and international talks. Sir has also published 33 research papers in national and international publications. Sir has very large biodata, which is not possible to deliver here. Thank you, sir, for accepting our invitation and joining us today. With this, I invite Honorable Dr. G.D. Kedar, sir, for his invited talk on the topic mathematical modeling in heat conduction. Dr. G.D. Kedar, sir.
Okay. Thank you, Nagesh. Okay. Are you able to see my presentation?
Yes, sir, but it is not first slide. I think it's 5th slide. It is visible, but on 5th slide.
Yeah. It's, I'm going to do the slideshow there. Okay. Now you can see
sir.
my first slide. Yes.
Yes, sir. It is visible now.
Yeah. Okay. Am I audible properly? हेलो, मेरी आवाज आ रही है आपको अच्छे से?
Yes, sir.
आ रहा है.
Okay.
You are audible.
Yeah. Okay, so the chairperson of today's technical session, Dr. Sisodia from Chandrapur, the organizers of this conference, the faculty members of Gram Gita College, and the dear participants. Today we are joining here from our places, and this is a common platform to have a healthy discussion on the research, rather the various branches of mathematics, particularly if we'll think about this technical session. So obviously you all are contributing through your research papers to be presented over here. My topic of discussion is mathematical modeling in particularly heat conduction. Actually, when we think of the mathematical modeling, it is actually very interesting topic of mine, because I always think that the research which is to be done through the mathematical modeling can be a very useful, because it can avoid much of your experimental work to predict something. You need not to go through the trial and error method every time. Instead of that, if we'll make some certain kind of model or the theory in mathematics, and by taking various parameters, changing their values, you can easily predict the resultant of the experiment to be done actually. So instead of going, or rather we can say that the mathematical modeling is the replacement for the trial and error method. And that's why mathematical modeling is very famous in the engineering field. To predict the much more things, you just can use the mathematical model for the different situations. So I am Ganesh Kedar. I am working professor and head Department of Mathematics. I welcome you all in this session. And this is my department, which is situated at the Amravati Road, Nagpur. We have MSc program, PhD program, and from this year we have started here 2 undergraduate programs also. One of that is BSc in drone science, and another one is BSc in cyber science. And both of that courses are with the major of drone and cyber. Mathematics is in minor role in that courses, but that is actually the apprenticeship embedded course. That's why we have made MOU with the industry. That industry itself is conducting the classes regarding drone science and cyber science. They will provide the apprenticeship, which will be on the basis of stipend in the 3rd and 4th year. Means complete 1 year will be of the apprenticeship there, and after that, that industry will also provide the job opportunities to the students who are doing the BSc in particularly cyber science and drone science there. So overall now our department is conducting UG, PG as well as research programs in our department. So here now, if we'll see the research and mathematics, many of the mathematicians have very interesting quotes regarding this. As if we'll see, the Bacon said that mathematics is gate and key of the sciences. And mathematics as a natural science, Euler says, mathematics is the most perfect of all natural sciences since it permits exact predictions. Now, you will see all these mathematicians, they were not only the mathematicians. Many of them were working in the field of physics or engineering, rather. We can say many of them who worked after 18th or 19th century. They are they are coming from the various fields there, but they are using the mathematical models as a very effective tool in their research, and so that's why they added some valuable knowledge to the field of mathematics, and so that we can call them as mathematicians also. So if we'll see the research, particularly research in mathematics, if we'll see, so research is actually to be done for the sake of mathematics itself. If we'll go 300 years before Christ and go to the Euclidean era, at that time, mathematics was just done for the sake of mathematics itself. But what they people have done, before Christ is now becoming useful in the 21st century, or particularly in the artificial intelligence era. So we are finding out some applications of the knowledge of mathematics which was created before 2500 years ago, and that is now becoming useful. So that the work in mathematics done for the sake of mathematics itself only is also more or less will become, or maybe in future that will become a very important tool for the survival of the society or for the betterment of the society. So that rather I can say that the mathematics is actually serving the humanity. So because it is actually the man-made, but which is observing the nature and making the relation between the different kind of aspects of the nature through the language of mathematics, and one can have the very interesting model which can be used in different situations later on. So actually it is a very systematic investigation aimed at expanding the body of mathematical knowledge through the discovery of new theorems, concepts, and relationships within the established axioms and frameworks. That is actually created in mathematics there. Now, what we have to do when there will be a certain kind of problem in front of us, then what we have to do? Rather, we have to identify the variables and we have to identify the interrelations between them. Just thinking on that, you can easily predict or you can easily make a certain kind of mathematical model. And by using that mathematical structure and along with the all kind of properties or axioms or different kind of structures, mathematical structures, which are already studied or which is already available in literature, can be used so that we can find a very fine solution for the current problem over there. So that it is very necessary to think mathematically when we see anything over there in the nature or anything what we want to create there. We always use the spectrum of mathematics to see it, so that you can make a very powerful tool to understand that phenomena, and you can find the fine results or the conclusions through it. So that's why mathematics is very important. So it is regarding the mathematical modeling. So what is mathematical modeling actually? Mathematical modeling use the same cheese which we can use for the various kinds of experiments over there. That is just like raw clay. And through that raw clay, we can make a kind of structure which will be in the form of bricks. And by performing certain kind of operations on it, it will becomes very useful there. Because nowadays, as you know, we cannot use the raw clay to make our houses. If we have to build the houses, obviously we need the mathematical structure there through the clay, which is already made by clay, but which is a very structured material there, which can build a very strong houses over there. So to make that useful, the clay to make useful, we need to go through the kind of structure, and rather we can say that it is through the mathematics we must go over there. So the mathematics can be used in field of science there for the as we know that to understand the complex phenomena or the to make the predictions, and for all that things you can by using all them you can build a theory also which can be useful for the future, and we can have certain kind of test for the hypothesis. So that kind of test is also can be made by the mathematical tools there. So easily you can test any kind of hypothesis in any kind of science over there. So these are some steps in the mathematical modeling. First of all, it is regarding the formulation. You have to define some variables there, identify their interrelations, and to try to make or try to formulate the equations for that kind of observations there. And then you can have certain kind of mathematical structure over there. After that, we have to make the analysis of it. Now, to analyze that kind of mathematical model, we can use the different tools in mathematics, which is already present in the literature. And that structure can be used to analyze the mathematical model which we have made over there. Now, the third step is validation. That validation can be done through different kind of modes of the operations. Just like you can perform the experiment to validate your result, or you can go in certain kind of mathematical model which is in past of the, or which is in the history of the mathematics, and you can compare your results with that so that you can validate it. There are certain kind of tests, mathematical tests there. If we make certain kind of series, or you can have the some kind of test over there through which, or the you can make the sure that the mathematical model you are using is a well-defined model. Well-defined model means it is approaching towards the right thing, or which is converging towards the desired results over there. That is very necessary. If that mathematical model actually converges to your expected resultant there, only then that mathematical model will be of some kind of use over there. And once it is validated over there, then you can say that it is a well-established model. And then by using that model, you can predict much more things. You can simulate the results so that you can have the desired results over there. And then you can go for the big experiments on the basis of that mathematical calculations. Okay. Now we are proceeding to the actual mathematical model which we use in our research. That is the mathematical model of heat conduction. So actually, heat transfer is the branch of engineering science which studies the transfer of energies solely as a result of temperature differences. So that's why mostly the engineers from the mechanical stream face the problems of heat transfer, and they used to study the heat transfer over there. There is another branch of mathematics which is, or rather the engineering, which is thermodynamics. And this thermodynamics actually studies the heat and work interactions of a system with its surroundings. So by using certain kind of physical laws and particular laws, this theory of thermodynamics, or the heat conduction, is well proved and used there. In 1769, James Watt, who stated the first law of thermodynamics. What the first law of thermodynamics says? That is the difference between sum of heat transfer interactions and sum of work interactions is actually the energy change. Here you can see, can you see the cursor? Yes?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
कर्सर दिखाई देता है ना? Okay. So this is the equation. You can see del Q minus del W is equal to del E. Actually, this is the change in the energy of the system. This is the heat interactions, and this is the work interaction. You will see the difference between them. That is actually the change in the energy of complete system. This is the first law of thermodynamics. Now, if we'll see this first law of thermodynamics, it is actually the fact which is observed by the many of the researcher or rather working in the field of heat transfer over there. But here, if we'll see this equation, there is no any kind of time involved in this equation. But as we know, according to the second law of thermodynamics, actually that is a entropy conservation. The system which is unstable, that always will have the exchange of the entropy with the surroundings there, and so that will becomes after certain period, it will becomes a steady state. So when the system is going to change its state according to the time over there, so that's why the time factor must be here in this equation, so that it will becomes a meaningful one. So we can make here this as a rate equation. Just we are taking the rate of change of here this heat transfer with respect to time. Means you can say that that is a derivative of Q with respect to time. So which is denoted by here small q, which is a heat flux there. And the rate of work change is to be given by W. And here it is a rate of change of energy with respect to time. Now, once you make it as a rate equation there, obviously it becomes very interesting now. You can say that the rate of change of heat transfer and the rate of change of work interaction, if you take the difference between them, then you can just find out the rate of change of energy in the system over there. Now, this equation is very interesting. But if you see this equation as an interesting equation there, and here this W term is added over here. Here, if we consider here this block, now in this block, we can see the equation that is the characteristically doesn't contain the information of time, or if we'll consider that time there. Now we assume here for the simplicity, actually we ignore the term of W. So that's why you can easily consider the only the heat transfer related with the energy change over there. So to make it, we consider here this block. Now we assume that there is a heat transfer from the left to right in this. So we consider here this gray color as a small element of that body, in which the heat is entering Qx at the end X. And suppose heat is leaving that element at X plus delta X, and that leaving heat is supposed to be Qx plus delta X. Now, obviously, the heat entering to this element will be larger than that of the heat which is leaving this element. So, when it enters here and it leaves here in some quantity, obviously some quantity is lost during this travel, during this element there. So that quantity we have to calculate there, or we can say that some heat is entering in this element and some heat is leaving it. So the difference between these two is nothing but actually the energy change of this element, isn't it? Means if we'll see there, now some जो हीट लेफ्ट साइड से एंटर करेगा और जो हीट राइट साइड से बाहर निकलेगा, अब दोनों का जो फर्क है वो फर्क मतलब होगा कि द हीट विच इज एक्चुअली लॉस ड्यूरिंग द ट्रैवल ऑफ दैट एलिमेंट. अब उस एलिमेंट में अगर वो हीट लॉस हुआ है तो ऑब्वियसली अकॉर्डिंग टू द एनर्जी कंजर्वेशन लॉ कोई एनर्जी लॉस या कोई एनर्जी क्रिएट नहीं की जा सकती. सो ऑब्वियसली जो हीट लॉस है दैट इज एक्चुअली यूज्ड to do something, some work is done over there. अब वो work done क्या है actually? That is nothing but the energy change in that particular element over there. And so that's why you can say, or you can say that here now, the amount of heat entering the element minus amount of heat leaving the element is nothing but actually the change in the energy of that element. Okay, now if we'll see this equation, we'll have the two sides of this equation. Left side, it is the difference between heat entering and leaving. Means you can say that the left side is actually the heat transfer term. And what is right side? Right side is the energy change in that element. Now, how can you establish this relation, or how can you check that this equation is correct? For that, obviously, we must have certain kind of measurement of the left side. Means we must have certain kind of measurement of the heat transfer. मतलब हीट ट्रांसफर, कितना हीट ट्रांसफर हुआ है, कितना हीट एंटर हो रहा है, दैट वी मस्ट नो. और अगर राइट साइड देखेंगे आप, तो इट इज एनर्जी चेंज इन दैट एलिमेंट. अब एनर्जी चेंज इन दैट एलिमेंट अगर आपको फाइंड आउट करना है, तो आपको एनर्जी मेजर करते आना चाहिए. मीन्स लेफ्ट साइड, इफ वी हैव टू अंडरस्टैंड द लेफ्ट साइड, हमको हीट का मेजरमेंट होना चाहिए. एंड इफ विल सी द राइट साइड, we must be able to measure the energy change in that. But unfortunately, both of that are not available. कोई हीट को मेजर करने का कोई मेजरमेंट तरीका हमारे पास नहीं है. As well as we cannot measure what is the change in the energy there, unless and until it is come to role of the kinetic energy there. तब तक हम नहीं पता कर सकेंगे कि how much energy change of that element have been done during this complete process there. So obviously this is the equation which is according to the observation of the nature, but this is not actually the measurable. Both sides are not measurable there. So to make this both of that as a measurable there, first we'll target the energy side, means right side we can target there. Energy. Now, if we consider U as a specific internal energy, what is specific internal energy? That is energy per unit mass. Because it is an energy per unit mass, means we require the mass of the body, complete mass of the body. Now, we have here this rho. Rho is the density. So density means it is a mass per unit volume. And if we multiply that mass per unit volume by the volume, complete volume, this capital A is the cross-sectional area of this. The cross-section area multiplied by here the length of this element, delta x. So obviously we can find the volume of this complete element there. So that volume of element is A into delta x. The mass per unit volume, which is density, if we'll multiply it, you are measuring actually the mass of that complete element. And if that mass is multiplied by energy per unit mass, which is the specific internal energy of it, small u there, if we'll take this measurement over here, you can just find out the complete energy in that element. Now energy become measurable. Consider all these terms in the, if we consider this U, which is the specific heat over there, then, and the density, if we'll find out for any kind of material, which is actually experimentally, you can just find out all of them. So you can, now this energy becomes measurable through means of this specific heat. So we have now here the energy measurable over here. Now the change in the internal energy, how can you measure in particularly here in this problem, because we are transferring the heat through that element. So to transfer the heat through that element there, obviously the heat which is remaining with this element is used to change the energy, as well as it is used to increase the temperature of that. Actually, the temperature is rather you can say that the measurable form of the heat remains with that element. So that if we consider that the dt is the change in the temperature, and if we'll consider that small c as a specific heat. What is specific heat actually? It is a heat required to increase the unit temperature in unit time. So unit temperature in unit time. So total time, if we multiply it with c, then you can find the change in the specific internal energy. So du can be taken as cdt. Now dt is measurable. Change in temperature is measurable. You can just measure the temperature change of that body by using the thermometer there. And so now the internal energy change is becoming here the measurable. So by taking this now, if this E is equal to this rho A delta X into U D, so that's why it will be D means change in the energy will be is equal to rho A delta X as a constant will remains as it is into du, and du is taken as CDT. So that's why you can establish the relation or equation dE is equal to rho C A delta X into dt. Now you can see the right side is completely measurable because all of them here this are the constant, whereas dt is the change in temperature. So just measuring the temperature of that body and finding out the change in the temperature, you just can find the energy change of that element there. And if we give the time duration for that, then you can see that dE by dt or del E by del T will be is equal to rate of change of energy with respect to time will be is equal to, now here this constants will remain as it is. It is a rate of change of temperature with respect to time. Now see, the change in energy is established or find out in terms of the change in the temperature of that element, and just we can use the thermometer there to find out the change in temperature, and so that's why automatically energy becomes measurable. So in this equation which we have taken over there in consideration, here the right side is becoming now the measurable, but still because the right side is measurable but left side is not measurable, so that's why again the establishing this equation is not possible, because this right side is observed or the calculated over there, but the left side is not calculated. The equation cannot be established. So to make now here this left side also measurable, in the year of 1822, actually this phenomena was experimentally proven by Biot, and after that theoretically it is proved by Fourier, and that is a very well-known law which is known as the Fourier law of heat conduction. So for the left side, now you can go for this. Here the Q, what is Q actually? It is a rate of change of heat transfer during the time. So this heat transfer rate is depending on certain parameters there. What parameters? The first one is the cross section area. जितना ज्यादा एरिया होगा obviously उतना ज्यादा heat transfer होगा, simple. So that you can say that Q is directly proportional to cross section area. Second thing, it depends on the temperature change. इस लेवल पर या इस सरफेस पर कितना टेम्परेचर है और इस सरफेस पर कितना टेम्परेचर है. इधर कम टेम्परेचर होगा, इधर ज्यादा टेम्परेचर होगा, then and only then heat will transfer from this side to this side, obviously. So that's why जितना ज्यादा डिफरेंस होगा टेम्परेचर का उतना फास्ट हीट ट्रांसफर होगा. So that's why heat transfer is also proportional to the temperature change or the difference between the temperatures there at that two different points. So that Q is also directly proportional to the change in the temperature, and it is inversely proportional to the delta x. Obviously जितना ज्यादा ये width होगा इसका उतना ज्यादा समय इसको ट्रांसफर होने में लगेगा. So heat transfer होने का जो संबंध है वो it is related with delta x. So it is inversely proportional to delta x. And so that one can establish here the relation, because Q is proportional to A, directly proportional to the temperature difference, and inversely proportional to the length of that element there. And so that's why you can consider here Q is equal to K, which is a proportionality constant, which is also known as the thermal conductivity of the material. So you can have this Q is equal to K into A into Tx minus Tx plus delta x divided by delta x. Now, it will consider here this as this ratio to be considered with the assuming that this delta x length is becoming narrower and narrower and narrower. So in that case, what will happen there? We have to reduce the delta x there so that we can have the local quantity of all that. So that we have to consider the limit or the limiting case of this ratio with delta x approaches to 0. So when we consider limit as delta x approaches to 0 of Tx minus Tx plus delta x divided by delta x there. But this can become meaningful if we'll take this Tx plus delta x on the left side minus Tx. Now it is just limit as delta x approaches to 0, Tx plus delta x minus Tx divided by delta x. According to the first principle of derivative, it will becomes the derivative of capital T with respect to delta x. And to make here this Tx plus delta x on the left and Tx must be on this side. Actually, Tx plus delta x is smaller than the Tx over there. And so that's why we must take the negative sign outside. So that we say that in the heat flux, actually, the negative sign introduced over there because the fact that the temperature flows or the heat flows from the larger temperature to lower temperature there. So that's why mathematically also you can see here it is just this minus sign is taken outside of this to take here this as a Tx plus delta x minus Tx. And after that you can have here now here this limit as according to the first principle of derivative, you can write that as a derivative there. So the Q will becomes minus Ka del T by del x. And so that this value can be put here for this value there. Now Q, this Q is calculated. Now we can see we can calculate Q at x plus delta x. That will be equal to, according to the Taylor's expansion, it is a Q is a function of x to be considered over here. And we have to calculate Q at x plus delta x. So by Taylor's expansion, it is Qx plus the length delta x multiplied by first derivative of Qx plus delta x square divided by 2 factorial into second order derivative of that on all them. So second order derivative and all higher order derivatives are ignored over there to make the relation that Qx plus delta x is equal to Qx plus del Qx by dx delta x. Now taking this Qx on this side, you will get Qx plus delta x minus Qx will be is equal to derivative of Qx with respect to x into delta x. And what is Qx actually? That we can see from this here. So this value of Qx can be put over here so that you can establish here this relation. So now you can see that the left side is also becoming measurable over here because the temperature change you can just calculate over there. So both of the sides here, this left side and right side both are related with the temperature change, and you can establish the relation between them. So it was a physical phenomena, rather natural phenomena there, that the heat get transferred from the higher temperature to lower temperature. And once this Fourier law and the Wyatt has experimentally proven there, and so this Fourier law of heat conduction gives the meaning, mathematical meaning to the complete phenomena over there. And then it is a very well-known mathematical equation now, which is known as the governing equation of heat conduction. So that heat conduction equation is established over there, that the K into second order derivative of T with respect to X is equal to rho into C into the first order derivative of temperature with respect to time. So both sides, if you see there, here we are using the space variables on the left side, while the time variable on the right side. So that's why temperature is now becoming the function of the space variable as well as the time variable also. And one can solve this equation easily when the situation is given and the boundary conditions are given there. You can easily find out the temperature change over there, and according to that you can study the complete heat transfer from the one place to another place there. Now, and after that, means in 19th century and afterward, the heat conduction equation becomes very useful to solve many problems of the engineering, and also you can predict much more things there before going the experimental use of it. Now, और समय है हमारे पास नागेश? Yes. Hello.
Hello.
Yes,
Hello,
sir, you
sir.
can continue, sir.
Yes. Do we have some time, more time there?
Yes, sir.
Yes, yes.
Okay, okay. So this is the mathematical model of heat conduction equation. Now, before this, I'll go back again to this slide here. Here, for the further calculations, that's the actually first law of thermodynamics gives us here this equation, that is Q minus W is equal to dE by dt. Means here actually the difference between heat interaction and work interaction is actually the change in energy. But to make this model simpler, in that case, we have considered only the heat interaction and not work interaction over here. And by taking this equation, we have established the heat conduction equation. So here this W is actually the ignored over here. But when we go for this complete heat conduction equation there, here this gives us here left side gives us only the heat interaction, and the right side is the energy, total energy change in that system there. So if we'll add here again the work interaction term to this heat conduction equation, then that becomes a non-homogeneous heat conduction equation. The equation which we have taken over here is a simple, and it is actually the elementary heat conduction equation. After that, there are much more changes in the heat conduction equation also, because this heat conduction equation actually predicts the infinite speed of energy wave over there, which is not possible. The energy wave is not having an infinite speed. So to avoid that paradox, actually, after certain time, the one more relaxation time is added in the heat conduction equation to predict or to give the finiteness to the propagation of heat conduction. So that is the different thing again. This equation is modified many times there for the different kind of situations later on. But here now, when we add the heat work interaction term over here, that is taken as a heat source for the heat conduction. Now that heat sources are of many kind there. As we know that the magnetism is also one of the cause of the heating of the body. And magnetism, what is the magnetism? So we can go for the magnetism through two kind of modes there. One is known as a eddy current, and another one is called as the hysteresis loss. So both of that terms you can easily understand over here. So actually in 1824, the Francois Arago, who is observed that the most conductive bodies could be magnetized. So, and after that, after the 10 years, Henrik Lenz, who stated one law which is known as a Lenz law. The direction of induced current flow in an object will be such that its magnetic field will oppose the change of magnetic field that causes the current flow. Means that, as we know, Faraday and the Lenz's law, if we consider all them, the Maxwell's have done the combination of all that laws over there to study the electromagnetic waves later on. So according to these laws there, or the, if we see the Francois Arago over there, that they proved that the magnetic field will create or may create the electric current, as well as the electric current also having the magnetic field around it. So magnetism and electric current are actually the combined mechanism over there. So according to that, now we can perform a simple experiment to understand the phenomena of the eddy current there. If suppose this is the rectangular plate of a metal which is moving from left to right, and suppose there is a magnetic field which is placed over it. Now, when this magnetic field will act on this metallic plate there, and because it is moving, the change of magnetic field does happen over here. Means जैसे ये प्लेट इधर से एंटर करेगा, तो at that time magnetic field, you can consider that as a rate of change of B with respect to time, dB by dt. You will consider there, that will be positive at this end. And when it travels through it, so this metallic plate will observe or which will be exposed to the changing magnetic field, and the changing magnetic field actually creates the electric current in that metallic plate over here. We can easily understand the phenomena there. Here you can see this metallic plate will have some free electrons over there. And when this plate is in this direction V, and here the B is acting downward over here. So the Lorentz force, which is the drag force, you can say, is actually act on the electrons, which are the free electrons in this plate. Means if we'll say F, which is a force, that is just a cross product of this V and B there. So that F will be equals to, actually you can consider that as a Q multiplied by B cross V. So the cross product will consider of them by using the right-handed system there. Obviously that force is acting at the rear side of this plate there. And due to that Lorentz force, actually the free electrons are going to move in this plate over there. And when that moves in the here, because we can change, consider the positive change of the magnetic field, and at this end it is a negative change in. So that's why that electrons will go rear here, and then again, because that field is going to change over there, it will returns again. And so that's why you can see that such kind of eddies of the currents have been produced in this metallic plate over here. And this kind of electric current are called as the eddy currents there. So this eddy currents actually creates the magnetic field also, so that the induced magnetic field is acting downward. According to the Lenz's, the magnetic field produced by these eddy currents will oppose to this. So the magnetic field around these eddy currents will oppose to this original magnetic field, and here it will have the attractive force over there. So at one end, it is the repulsive force. At the another end, it is the attractive force over there. And so that's why it will restrict this plate to move just on the right side there. There will be certain kind of force which is observed by this plate over here. But because actually this plate is moving from left to right here, so that's why obviously that will oppose the drag force which is acting on that plate. और ये जो ड्रैग फोर्स उस पर एक्ट हो रहा है, ये ड्रैग फोर्स एक्चुअली इसका जॉल हीट बढ़ाने में काम आएगा. So that's why when such kind of metallic plate is moving from left to right under the influence of this magnetic field, that plate get heated over there. So that heating is happening due to the magnetic field which is acting on that body over there. So that this kind of drag force are acting, and due to which that metallic plate will get heated over there. Now there is another phenomena. It is particularly about the ferromagnetic materials. If suppose this is a ferromagnetic material and if we place one magnet on this side, obviously all the dipoles of that will get aligned in this direction. It will again remove that magnetic field, and then if we'll put that on the another side there, obviously that dipoles which was aligned in this direction will align in the opposite direction there. And so that if we'll go on changing the magnetic field around this ferromagnetic material there, every time that dipoles are getting aligned on this side and then this side. So due to that their frictions there, that body can get heated again. So again, due to the magnetic field, the heating of the metallic or the particularly ferromagnetic material is getting the heat due to the magnetic field over there. So we can say that the magnetic field can influence the any kind of solid, and the heat content of that solid will get changed due to the influence of magnetic field there. So this magnetic field also can be taken as the kind of heat source for the heat conduction equation. And so by taking the combined equation of them, means the original heat conduction added the magnetic field over there, we can have the non-homogeneous heat conduction equation, and by solving it you can easily find out the effect of the magnetism on the conducting material over there. So we are using, this is actually the hysteresis loss which is due to this alignment of the dipole there, and by using it you can easily find out the relation between the induced magnetism and the produced magnetism there. So we use all these equations there, Maxwell's equations, to calculate the heat source due to the magnetic term there, and by using it we can have, ये इसके detail हम नहीं जाएंगे, so by using them we can have certain kind of calculations there. And here you can see the effect of the eddy current, which is we have already considered over there. In heat conduction equation, we are not using any other kind of heat source over there. Only the heat source is the magnetism of that material. And according to the mathematical calculations, we can observe here that this is the time evolution of the eddy current, then time evolution of the total heating to be considered due to the eddy current as well as the hysteresis loss. And by taking that, you can have the temperature change. Here, this figure 4 shows the temperature change there. This is the frequency of the changing the magnetic field. So one can easily observe that as we increase the frequency change over here, increase the frequency, the temperature contained in that body is going to increase. And after certain time, it gets the steady state effect of this. So at the starting of it, only the temperature is going to rise, but after certain time, it is becoming the stable temperature over there. But it is maintaining at the same level, not cooling over there. It is maintaining at the same level, but after a certain time, it is going to become flat, or rather you can say that in this form of the steady temperature there. So this is the observation of our research paper. So here there are certain some more things we study there. That is the thermal stresses also we calculate by using the heat conduction, because thermal stress is actually the mechanical term which can be affected by the heat content of the materials, and so we use to calculate the thermal stresses also. So all kind of stresses we can calculate over here. Magnetic stress is also calculated, and the figure shows the change in that quantities. So as per this research paper which we have considered over here, according to that, we have a definite change in the heat content, as well as it affects the heat conduction, and obviously according to that there will be the change in the stresses also. So the induced magnetic field actually gives rise to the stresses, or the particularly thermal stresses in the metallic body there. So these are the all references which are used for the preparation of this complete lecture, as well as for our paper which we have studied, the effect of eddy current and hysteresis loss on the heat contents of the body over there. Okay, so thank you very much, and I am also very much thankful to the organizers to give me an opportunity to interact with you people. So I am very much thankful to the organizers, as well as I am very much thankful to you people also for the patient listening. Thank you all.
Yes, complete box for that.
Thank you, sir, for your insightful presentation and sparkling ideas. If anyone have questions, you can ask.
Yes, anyone asking something? I cannot hear properly.
Hello.
Hello.
Am I audible?
Yes.
Hello.
Yes, sir. Yes, sir.
Yes, sir. Oh, thank you, Dr. Ganesh, sir. You given an elaborate mathematics. Hello.
I think this SS Aswale
Yes,
is
sir.
saying something.
Yeah, someone is speaking. Sir, I am Professor Bhutma, sir, Department of Statistics, Andhra University, Visakhapatnam.
Yes.
Yes, sir. So your lecture is very informative and inspiration lecture, sir. I am a statistician, but statistics, the backbone is the mathematics. Without mathematics, there is no statistics. But
Yes.
the mathematics generally, mathematicians are preparing mathematical models, validation and adequacy of the testing and estimation of the parameters. If you want to test, just generally we are applying statistical tools and techniques, but the formulation of mathematics model is purely depending on mathematical subjects, right? So again, very inspirational and information, sir. Thank you.
Okay. Thank you.
Thank you, sir.
Yes, yes. Actually, statistics is also a branch of mathematics, and because we do have a certain kind of test also in the statistic for the validation of the mathematical model also. Okay,
Yes, sir.
thank you.
Oops.
Nagesh sir, please spotlight the persons who are talking, sir. Thank you, Ganesh sir, for your valuable and thought-provoking lecture, sir. And thank you so much, Professor B. Muniswamy, sir, for joining with us. Sir is from Andhra University, professor in statistics department. And sir, please meet Dr. Ganesh sir from Nagpur University, HOD Department of Mathematics. Sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank
Thank you once again.
Yes.
Followed by this.
Should I stop this presentation now?
Yes, sir. You can stop now.
Yeah.
Is anyone have question? Anyone? Okay, sir. You can stop. Okay. Followed by this, we have now oral presentations. Each presenter will get 7 minutes to present his presentation, followed by 2 minutes for the discussion from audience and judges. I now request our respected chairpersons, Dr. Sisodia sir, and co-chairperson, Mr. Ankush Ramtige sir, to kindly take charge for the session. They will introduce the presenters, facilitate the discussion, and ensure smooth conduct of technical proceedings. Sisodia sir.
Okay. Shall I leave now?
Yes, sir. Yes.
Okay. Okay. Thank you.
You can stay. You can stay if.
Yeah. But I am having certain some another assignment.
Okay, sir. Okay, sir. Thank you so
Okay.
much.
Thank you.
Thank you so much.
Very much.
Hello. Hello, Ankush sir.
Hello.
Hello.
Saram sir.
Hello, sir. You can start now presentations. एक मिनट
मी यावर पण लॉग इन मी भले इकडे तिकडे फिरत आता मला स्क्रीनशॉट वगैरे काहीच नाही आता चेंजच केली
कायची स्क्रीनशॉट आहे चालू पीसी वगैरे होते Ankush sir, mute yourself. Unmute yourself. सिसोदिया सर आपका आवाज आ रहा लेकिन नहीं सर आवाज नहीं आ रहा नहीं रहा
I request the host to spotlight accordingly. Those who need to submit, please spotlight on them.
Hello, Nagesh sir.
Yes sir.
Able to hear me?
हाँ अंकुश आपका आवाज आ रहा है.
Okay, okay. Shall we proceed? Sir, you are not audible, Sisodia sir. Sir, check your audio setting.
Or if not, you quit from the meeting, again you join, sir.
Yes, yes. Sisodia sir, you must exit and once again join.
Nagesh sir, meanwhile, you can announce the next person, I think.
Okay.
So, Nagesh sir, shall we wait for? We just proceed for calling the names of presenters.
I think Sisodia sir have joined. Unmute to them.
Sir, change your audio settings. So, dear sir, recheck your audio setting. Select a microphone, whatever you have.
Select microphone setting.
अभी बताइए सर, आ जा रही है?
हाँ सर, बिल्कुल आ रहा है, आ रहा है.
हाँ ठीक है सर, वो क्या जूम में अभी उतना आइडिया नहीं था.
ओके, कोई बात नहीं सर, कोई बात नहीं.
हाँ
Okay, sir. You can now start.
हाँ. सो रामटेक सर, प्रेजेंटेशन स्टार्ट करें?
बिल्कुल सर, बिल्कुल.
सो
सर, मैं
सीक्वेंस.
नाम.
हाँ यस सर, यू कैन.
Okay. So we have our first presenter, Miss Rosa Ajanna. She is going to present her paper on numerical study of entropy in a non-Newtonian fluid flow through a microchannel with electromagnetic and pollutant effects. Miss Rosa?
Yes, sir.
Okay.
Am I audible, sir?
Yes, yes. You proceed.
Yes.
Okay, sir. Good afternoon to everyone. I am Dr. Roja, working as Assistant Professor in Department of Mathematical and Computational Sciences, Sri Sathya Sai University for Human Excellence. So my specialization is fluid mechanics. Today I'm going to present one of my research article, which is entitled Numerical Study of Entropy in a Non-Newtonian Fluid Flow Through a Microchannel with Electromagnetic and Pollutant Effects. So this is the mathematical formulation of our work. The geometrical interpretation is as shown in the figure. Here we consider electrically conducting incompressible laminar flow of Cassan couple stress fluid flow through a vertical microchannel separated by a distance 2a in presence of constant longitudinal pressure gradient dp by dx. The coordinate axis x is in the flow direction and y-axis is perpendicular to it. The uniform magnetic field B0 is applied normal to the plates. The left plate is placed at xi equal to minus a and the right one is placed at xi equal to a, having hot fluid temperature and ambient temperature respectively. Without loss of generality, we have assumed that both the plates are infinitely long so that both velocity and thermal fields are fully developed. So based on these assumptions, the governing equations of momentum, temperature and concentration equation can be written as C equation 1 to 4. Equation 1 and 2 are the momentum equations and 3 is the temperature equation and 4 is the concentration equation. And we have incorporated convective boundary conditions to strengthen this analysis that we are defined in equation 5 and 6. And also the expression for external pollutant source function will take the form see equation 7. So after introducing the appropriate dimensionless parameters that are defined in equation 8 to the given equation, to the governing equations 1 to 6, we get the reduced nonlinear system of ordinary differential equation, see equation 9 to 12, and the corresponding reduced boundary conditions. You can see equation 13 and 14. Here we obtain some dimensionless parameters, namely Reynolds number Re and a constant pressure gradient parameter, and the GR Grashof number beta Cassan parameter, and S is a couple stress parameter, HA Hartmann number are magnetic parameter, M is a Hall parameter, and BR is a Brinkmann number, and PR Prandtl number, and delta star lambda star are the local and external pollutant source parameters, and BI1 BI2 are the Biot numbers for each plate. These are the expressions for the dimensionless parameters. And the entropy, the volumetric entropy generation equation can be written as equation 15. After applying the dimensionless transformations, this will take the form C equation 16. And the Béjan number is defined as in equation 17, the ratio between the entropy generation due to heat transfer to the overall entropy generation. Coming to the discussion of the results, we have utilized Runge-Gupta-Fehlberg-Pofifth-Adler method along with Schutig technique to find numerical solutions for various parameters that are involved in the problem. So here I have included a few parameters, and this figure 3 represents the impact of Casson parameter on axial velocity, transverse velocity, entropy generation, and Béjan number. With increasing values of the Casson parameter, intensifies the both axial and transverse velocity due to reduced deformation resistance. And see the entropy generation equation in C. In the channel central region, the entropy generation is enhances due to higher velocity gradients, and near the left plate the effect is decreases, and towards the right plate the effect is uniform. It shows a smoother flow. Coming to the Béjan number profile, due to more heat transfer irreversibility towards both the plates, the Béjan number is enhances, and the dominance of viscous dissipation is noticed in the channel central region. It shows a Béjan number is decreases in that region. So these are the profiles for inverse capacitance parameter. Increase in the inverse capacitance parameter enhances the axial velocity due to reduced microrotational microstructural behavior of the fluids, allowing the fluid particles to more align more efficiently and move with the less resistance. And the transverse velocity indicates that enhanced momentum transport across the boundaries. Coming to the entropy generation profile, this shows a improvement in the improvement with increasing inverse capacitance parameter. So driven by elevated shear rates and thermal dispersion due to accelerated flow, reflecting the thermal and viscous losses in a system. Coming to the Béjan number profile, it shows the viscous dissipation is the primary contributor to the entropy generation. And in both the profiles, see in the channel central region, the effect is uniform. So this spatial distribution suggests highlights applying the thermal management strategies at the boundaries to reduce irreversibility, heat transfer irreversibility losses. Figure 5 represents the impact of Hall parameter on primary velocity and secondary velocity. So with increase in Hall parameter, the axial velocity is enhances due to a Lorentz force is more aligned with the flow direction with increase in Hall parameter. The opposite trend is noticed in the a transverse direction due to the momentum redirects it. And with increasing values of the Hartmann number, the velocity shows a decreasing nature because a resistive type of force exists in the fluid which opposes the flow. So as a result, the velocity is decreases, and the opposite behavior is noticed in transverse velocity, transverse direction. So these are the profiles for each source constraint. Due to heat absorption behavior of heat source or sink parameter, the temperature is enhances throughout the microchannel, and also more heat is internal heat is more, so it means more heat transfer irreversibility. So as a result, the entropy generation is enhances, even though there is a slight decrement is noticed near the left plate. So this might be due to boundary stabilization effects. And the Béjan number shows the dominance of heat transfer irreversibility to near the right plate of the microchannel, while viscous dissipation effects dominate near the left plate of the microchannel. So these profiles represents the impact of local pollutant and external pollutant source parameter on concentration. So increase in these two parameters intensifies the concentration level within the microchannel. This is expected. A higher magnitude of external source results in a stronger pollutant flux across the boundaries, so resulting in a spatial diffusion and elevated concentration levels. Understanding the influence of these two parameters helps the engineers and designers to helps to modify the flow properties and sensor placements to enhance the filtration, detection, and remediation performance for high compact precision systems. And these insights have direct practical applications in the fields such as in the applications such as environmental microfluidic sensors, air or water quality monitoring, etc. So these are the key findings that we have summarized as below. So coming to the implication, limitation, and future work. So this work offers a valuable insights in the applications like microfluidic and biomedical systems, where precise control of heat, mass, and entropy generation is essential. Although this is limited to the laminar flow study and with idealized boundary conditions, the future work can be extended to the time-dependent three-dimensional flows incorporating nanoparticles. These are some references we have referred in our work. Thank you, sir.
Okay, any questions from the audiences? Okay, we'll move to the next presenter.
Thank you, sir.
Ms. Kavita Hiremath. She is going to present on exploring Eulerian and Hamiltonian graphs, a study on concavity and optimization. Ms. Kavita, is she here? Okay. Going to the next presenter, Mr. Sachin Lonare. He is also not here.
Call next. He is not
Okay.
present.
Next is Dr. Harshavardhan Singh. Okay, he is present here. Okay, Dr. Harshavardhan Singh, he is going to present his paper, formulation of flows of viscoelastic fluid in tubes. Harshavardhan Singh. Sir, unmute yourself. Harshavardhan sir, are you there? Unmute yourself. He is not responding. So we will move for further participants, sorry, presenters. Prafulla Parate. Okay. His name is also there.
Sir, good afternoon, sir.
Okay. Sir, Prafulla Parate is going to present his paper on unified thermoelastic modeling of micro elongated solids, a review of fractional and non-local frameworks. You can start now, sir.
Okay, sir.
Sir, unmute yourself.
Sir, yes. Sir, now the slide is visible, sir.
Yes, sir, go ahead.
This is a unified thermoelastic modeling of microangulated solid, a review of fractional and non-local frameworks. I am Praful Parate from NH College, Brahmapuri, and I'm just coming for that is the presenting the full length paper of unified thermoelastic modeling for non-related solid, a review of fractional and non-local frameworks. Now, introduction is what there are the this research is related with what thermoelasticity, and this is belongs to what some key aspects are there. That is micro elongated solid, generalized thermoelastic modeling, fractional memory colors, and non-locality effects. Now, just see that this research is developed a mathematical model to study how the micro-elongated solid materials respond to heat mechanical forces, and especially considering the memory effect, how the past effects are the present, fractional mathematical for precise modeling, non-local interaction, how the different regions of the material are influence each other, such as modeling in the useful in designing the analyzing the advanced material like nano composite, small material, and the biological tissues. Now, what is the abstract for this? This review is synthesize the recent advancement of modeling of micro-elongated thermoelastic solid using the fractional calculus and the non-local elasticity. Actually, this is the traditional thermoelastic theories often to fail the capture the intricate memory effect and the long range of interaction inherent the microstructured materials. And this is with the errant type of non-local elasticity, research has developed the robust frameworks that enhance the predictive accuracy for the stress relaxation and wave propagation and thermal damping. These papers explores the evolution of these models. There are the mathematical formulations and their
Sir,
applications.
sorry to interrupt.
Sir.
Sir, please proceed with your moving slides. You didn't change the slide.
Sir.
You are still on introduction slide.
Okay. Introduction slides.
Yes, sir.
Okay. This is study for the thermoelasticity where the thermal and mechanical fields are interact has developed the significant over the past centuries like the classical thermoelastic theories rooted the Fourier's law and Hooke's law assume that the instantaneous heat propaganda, that is the non-local propagation, that is the non-local stress and strain relationships. To address this limitation, the generalized thermoelastic modeling for Immers and the Lord and Sublime had introduced the single-phase log model for incorporating the thermal relaxation times, while the Green and Nagai has proposed the non-despective formulations based of entropy productions. Now, just that there are the parallel are these developments are fractional calculus gain the prominence for the ability to model hereditary and the anonymous diffusion for the phenomena. Now, in this Aryan non-local theory, the revolves the modeling of material with the microstructures by incorporating the special kernels that in account of long range interactions. These frameworks has successfully applied to nanostructures, porous media, and the composite materials. Despite of these advances, your unified frameworks had integrate the fractional derivatives, non-local elasticity, and micro-elongation effects remains the underdeveloped. Now, the gap analysis is there. The most thermoelastic modelers has neglected the micro-elongation degree of freedom, which are critical in biological tissues and the porous media. Fractional heat conductions law are rarely coupled with the non-local mechanical and formulation, limiting their predictive power in the multi-physics environment. Benchmarking the validation and technique, the fractional non-local models are understand and standardized the making the comparative analysis difficult. The few studies has embedded the fractional kernels directly micro-elongated field with the equation leaving the gap in the unified modeling approaches. The classical and generalized thermoelasticity. What is that? The foundational models that is Lord Schulman and Green Nagadi has introduced the thermal relaxation and energy dissipation and mechanism. However, there are the limited in the capturing modeling independent behavior. Their dual.
Rathe, sir.
Sir.
You are still on introduction slides and you have already moved further in your paper, reading your paper.
Okay,
So
sir.
can you please change your slide?
Okay. Now,
We are not able to see your further slides.
once again, sir, I am stopped sharing and again, sir. Now, sir, you are
Oh, yes,
visible.
sir. Yes, sir.
That is fractional calculuses in thermorealistic modeling. What is that? A fractional derivative of generalized classical differentiation enabling the modeling of hereditary and memory effect. That is capital fractional heat flux loss. What is that? That is Qxt, that is equal to minus k and del x alpha t xt upon del t alpha, where zero alpha is in between 0 to 1, and this formula it is equal to 1. This formulation captures the anomalous thermal diffusion and has widely adopted a fractional thermostatic model. That is Antekian Balangu fractional derivative. What is that? That is the d alpha t f of t b of alpha 1 minus alpha 0 to t integration of 0 to t e to the power e alpha is bracket in minus alpha 1 minus alpha t minus del alpha bracket, that is f dash of t into del t. That is, this operator has embedded the heat conduction and viscoelastic model to stimulate the long memory behavior. Now there is a exponential kernel function is there, that is a illegal non elasticity introduce the integral kernels to account the long range interaction non local stress strain relationship. That is sigma x is equal to, that is y x mod of x minus x dash c exponent x dash and del x dash. This particular effective modeling non scale materials and the porous media. Now, micro elongation and coupled field equation is there. That is, micro elongated solids and involves the additional degree of freedom, such as micro rotation and elongation. The coupled field equation
Sir, it
integrates.
is again stuck on the same slide.
Actually, what is the problem? I don't know. Actually, I'm changing the slide.
Now it is visible. Fifth slide, micro elongation.
Okay, that is momentum equation is that P del square u and del t square delta, that is sigma plus n delta phi. Micro elongation evolution is there. There is another formula is there. This is del square alpha phi del t square is equal to d del squared phi minus beta del phi plus sigma, that is delta u, and this is the fractional dual phase heat equations. These equations are unified the dynamic and mechanical thermal microstructural properties under the fractional and non-local regime. That is the. Now the next one is that is the application and the case studies. That is a geomechanism, that is modeling subsurface heat transfer with the memory effects, biomedical engineering, that is stimulating the thermal response in the tissue and microstructure, porous media, that is capturing the delayed the thermal waves and stress relaxation in the filtration systems. Now the next is the future direction is what? That is development of high kernels combining fractional and non-local features, embedding 3D visualization with the 2D figures for the enhanced clarity, extending the model to multi-phase and multi-scale systems, and the integration with the machine learning and the parameter estimation and the model collaborations. That is, the conclusion is there is the integration of fractional calculation and non-local elasticity into the thermal elastic modeling of micro elongated solids offers a powerful framework for capturing the complex and physical phenomena. This reviews has highlights the theoretical richness and practical relevance of these approaches, paving the way of innovations in computational mechanical and applied physics. That is, author contribution is there. I am, and my guide is there. Dr. Ajay K. Sharma supervising the critical revision and theoretical validation, and there are the some references are there where the all the materials are there for Irigan, Caputo, Antegena, and such things are there. And this is my presentation actually.
Okay, any questions from the participants, other participants? Okay, moving to the next presenter, Mr. Dilip Kumar Batri Narayan Sonil. Are you present here?
Yes, sir.
Okay,
Hello.
you start
Avaz
your
sir.
Am I audible,
we
sir?
start with your presentation,
Am I
and
audible, sir?
keep your elaboration as short as possible.
So actually, my research is in actually transdisciplinary. It will take more time, sir.
Sir, we have other presenters
Yeah,
also.
that's true. But actually,
So
I am
try to
merging the
keep
two
simple and
disciplines.
short.
I am merging the two disciplines, sir. It will take time, sir.
Okay, start then.
Okay. Is the screen visible, sir?
Yes,
Yes,
sir,
sir.
visible.
Proceed.
Okay. Okay. This is my introduction. I am Professor Dilip Soni from Chandrapur, and I am doing my PhD from Gondwana University. And this is all the information. My topic is mathematical aspects of mudra, that is hand gesture in psychoneurobic techniques. So already everyone has seen these type of mudras in the Ramdev Baba, by the Ramdev Baba, and every yoga person, we can easily see it. But actually what I am doing, I am merging these two disciplines, that is psychoneurobics, actually using mudra techniques, sound, and healing. It is actually a healing technique. So in that we are using mudra hand gestures, what we call it as mudras. So this is one of the psychoneurobic technique. So now this is the abstract that already we have seen. The next part is introduction. So in this introduction part, actually what I have said, that today's whatever be the today's environmental situation, everyone is facing the issues. Just a minute, sir. I'll shift here. Yeah. So everyone is facing the issues regarding the health. So everyone is now health conscious. So to remove the health, what everyone is doing, what exactly they are doing, they are going to the doctors and they are visiting the doctors. But that therapy is called as medicinal field. But along with it, some alternative medicine field is also there. And in this alternative medicinal field, we are using various type of therapies that we call it as, and it relieves within some time. Some therapies take more time. In the next part, this is a literature review. So I have just studied various type of literatures. So these all literatures are giving us the information regarding that the usefulness of yoga mudras, that we call it as usefulness of yoga mudras in curing of all type of diseases, or we don't call it as illness. So now we will move towards the mathematical aspects. So what exactly is the mathematical aspect that we are going to see here? So actually science is what? Can you see my hand, everyone? My hand is visible?
Yes, sir.
Hello.
Yes, sir. Yes,
so
sir.
this hand consists of 5 elements. What we call it as Pancha Tattva. That is Agni. So this thumb relates to Agni. This particular thumb relates to earth, air. And this particular term is related to the space. This finger related to air. And this little finger relates to the water element. So these 5 elements are actually in our hand, in our fingers. So this particular picture, everyone can see it. Just a minute. Yeah, this particular picture
gives the brief idea regarding the elements and related to the particular. So this element is giving us the particular information. Okay. Now, what actually is the mathematical aspects? So whatever the scientists have studied, they already have given the fact that fingers are actually continuously releasing vital energy to create electric waves, and this particular electric waves makes a aura. So mudras are actually performed. When we perform mudras, then what actually is happening in our body? It creates electromagnetic currents to flow along the body, and stimulate our conscious brain, what we call it as conscious center, and hence it increases the vitality, removing all type of pain, release of pain, stimulation, and all that. Okay. So now when we just go through this particular table, then this table is stating us that when we touch this, everyone can see my video. So when we touch the tip of the finger with the tip of the thumb, then it increases the stability of the related element, whatever the element we have discussed in the previous part. Then when we touch the particular finger at the bottom of the thumb here, then it decreases the related elements influence. And when we touch the tip of the base, that means just like this. So it stimulates the linked element, whatever is the element which are governed by this particular 5 fingers. Another factor is also there. When we put the our palm facing towards the sun or upward side or the sky, what we call it as, it actually receives the inspiration or energy. But when we put the hand in downward direction towards the ground, then our particular energy becomes grounded. In the next part, in mathematically, actually, this is the particular what we call it as fundamental energy equation of the body. So it particular states that whatever is the energy stored, these are the meanings of these particular symbols. ES represents the energy stored in a body. EC, whatever the energy we consume, and now this energy consumption is from what? From whatever the food we eat, or whatever the solar energy or meditation part, or any other ways. Whatever are the different ways from where we can get the energy, those all energies are supposed to be the EC, means energy consumed, and EO represents energy out. So this we call it as fundamental energy equation. In the next part, we call this particular EH. EH means energy of a healthy body. EUH means energy of an unhealthy body, and EB is energy of a particular body. So whatever will be the change in the particular energy of the body is nothing but the energy of the healthy one minus energy of the unhealthy one body. So when we take a difference between these two energies, then we actually get the particular change in the energy of the body. So these are the meanings. So in this particular part, what we can say, this EUH means energy of the unhealthy body is actually nothing but the function function of what? Function of energy actually released, or energy reduced, or energy increased. ER represents the reduced energy and EI represents the increased energy. Next part, here we are going to perform various psychoneurobic activities that consist of sound, mudra, and color. Now this particular part shifts our energy EUH, means energy of the unhealthy body, towards the energy of the healthy body. Mathematically, we can write it as limit x tends to h, EX becomes EH, means energy of the healthy body. So these meanings are there. In the next part, we are going to see the fingers and its governing elements. So just now we have already discussed that here this thumb represents the fire element, what we call it as in Agni element. Okay. In the next part, when we see the index finger, this index fingers consist of air element, or what we call it as Vayu Tattva. In the next part, we can see the middle finger. It consists of sky element. It governs the sky element, or we call it as Skaya Tattva, Akasha Tattva. And in the next part, this is called as ring finger. So this ring finger is represented by capital R, and it governs the earth element. Okay, that we call it as Prithvi Tattva. And the last one, that is the small little finger. This consists of water element, or we call it as Jala Tattva. So these 5 fingers consist of 5 particular elements, Pancha Tattva. Now we'll move towards the various mudra equations. Now what are these mudra equations? So FE. Now FE means what? That we are going to see now. We'll first move this particular part. Yeah. FE is nothing but the finger governing particular element. Means element governed by this particular finger is nothing but the function what consists of all these 5 elements. That is fire, air, then sky, then earth, and then water. Okay. Then FT. FT is what? This is supposed to be the finger type. Now finger type means what? Thumb, ring finger, then this is middle finger, this is index finger, and this is little finger. FP. FP means what? Whether we are touching to the tip of the finger or we are touching to the base of the finger. Okay. And now PF. PF represents the function which represents towards the palm facing towards the upward direction or towards the downward direction. Now various mudra equations. So these are the equations and these are the meanings of these particular terms. Now here, if you can see my mouse, everyone can see the mouse? Hello? Hello? Am I audible?
Yes, sir.
Okay. So this plus sign here in these 2 equations, we have written here plus sign, and in these 2 equations, we have written minus sign. So this plus sign and minus sign, what actually it represents? It represents the increase or decrease in the stability of the related element. Now this FE just now in the previous slide we have seen, FE represents the finger related to the particular element. Now if we move towards the next part, then we can see that FT, this particular after right side of the equal to sign. FT, here T we have written, and here this is called as FT. Now what does it mean? It means the touching tip of the thumb with the tip of the another finger in this particular part. These are the four forms we can say. Okay. And if we join this particular fingers, tip of the fingers to the base of the thumb, just like this, then we represent it as FPB. Now what actually PFU and PFD represents? So it represents the palm facing upward direction or palm facing downward direction. So these are the particular equations governed by these particular symbols. Now mathematical aspects. So these are nothing but our particular equations that we call it as the G. G is what here actually? G is nothing but the gesture of the body. It is nothing but the function. Function of what? Element governed by a particular finger. Then this particular FT represents type of the finger, whether it is thumb, whether it is ring finger, index finger, or middle finger, or little finger. Then this FP represents the particular part of the finger. And last one is the PF. PF means palm facing towards the upward direction or downward direction. And this equation 14 represents the delta E. Delta E is what? Delta E is nothing but the physiological energy change in the particular body. Okay. So this is nothing but the joint function of EUH. Now EUH is nothing but the energy of the unhealthy body. G is nothing but the gesture. Gesture means whatever the mudras we are making, that. And the last one is the time. Time means for how much duration these particular fingers are, these mudras are made. Now This is the last our final result of this particular study. EC mudra is equal to delta E. So delta E, just now we have seen, it is nothing but the physiological energy change. And EC in the first equation already we have seen. EC in the first equation. EC represents the energy consumed. So this EC means energy consumed, but from the mudra conditions. So energy consumed from mudras is nothing but actually the physiological change in the particular equation. So this particular table I have prepared, where we have written various type of name of the mudras, various type of elements, that is air, sky, earth, water, everywhere. Then whether this element increases or reduces, there's this particular thumb we need to tip or base along with the finger, that is index finger. If we touch to the tip of the thumb and index finger tip, then palm facing, if we keep upward direction, this particular equation is governed. So in this way, we have prepared this particular table. Then these are the conclusions. The very first conclusion is diseases are nothing but the after effects of the loss or excess of energy. The second conclusion is this difference can be removed by various known or unknown medicinal fields. The third part is alternative medicine is nothing but a method which does not harm our body organs. The next conclusion is psychoneurobics is one of them. It is alternative medicinal field. Then this is nothing but this study particularly succeeded to apply mathematical concept to the mudra therapy. This is the major conclusion. And the last one is equation 15 is the result of this particular study. So now limitations of this research. So what are the limitations here? As per this, as per my research title, actually what I am going to do, we studied, this particular study covers only the mathematical aspect related to the use of mudra in psychoneurobics. The second limitation is only few equations which and their relations with the hand mudras, hand gestures, what we call it as mudras, various combination fingers. Only few equations we have generated. The third limitation is only psychoneurobics I have covered, which is one of the alternative medicinal field. Now future scope, this particular equation, there we can frame more such type of equations, okay, making various type of combinations everyone can see. So this particular mudra, if we can see, this particular mudra is called as Apana Vayu mudra. Okay, in this way we can make more and more combinations, which definitely benefits our health. Then more study can be done in this particular field of various alternative medicinal field. Then these are the references what I have studied. Then these are the references. Then we'll move towards the next part, that is question answer. So I have completed my presentation. And now if any questions or answers are there, then everyone can ask the questions. So at the last, I'll say stay safe and healthy. Thank you.
Thank you, sir. Anyone who wants to ask the question to Dilip, sir?
So, hello, sir. It was really a nice presentation. I want to ask one question. Which parameters or tools you use to validate this mathematical model?
Actually, this is not a mathematical model. Already there, I have merged two different fields. One is alternative medicinal field. So I have just tried to frame particular equations, which actually does not exist. I have studied so many journals and all that, but nowhere I got that particular mathematical equations. So I tried to merge the two different platforms, that is alternative medicinal field and mathematics. So I have just tried it at my level. So I have not yet completed it, but in the next research paper, my next research paper will be based on that particular path. What you asked us.
Thank you very much. Thank you very much.
Thank you. Thank you. Thank you.
Thank you, sir. This is Dr. Aruna from ICGICPMCs Foundation side. Actually, this is the one of the great and wonderful presentations, sir, which I had till now. I myself,
Thank you, madam.
myself
Thank you.
enjoyed a lot. Thank you so much, sir, for giving such an wonderful and actually this is the need of our also to know all these health benefits and health aspects which are to be related to the other sciences like mathematical science. Related to mathematical science, you had done a wonderful job, sir. Thank you so much. And it should not stop now with this. This must be reached to many people. I'll be contacting you in this regard, sir, in future.
Sure, ma'am. Sure. I'm welcome, sir. Actually, in this particular field, no work is done, madam.
Yes, sir. Yes, sir.
So I just tried to touch this particular aspect, and my title is only the mathematical aspect in mudra therapy. Yeah.
Yes. Please mail me, sir, all your details. I'll be contacting you. How much more reliable documentation we can do on this particular presentations.
Sure, ma'am. Sure. Thank you.
Thank you, sir. Thank you.
Thank you. Can I stop now for the presentation?
Yes, sir. Yes.
Okay, so we'll move further in the presentations. Dr. Vikas Kumar.
Yes, Ankur sir, you can call next participant.
Yes, I already called Dr. Vikas Kumar. Is he here? So his name is not appearing in the participant list. So we move further. Dr. Harshvardhan Singh. Okay. Miss Bhumika Pandey. Ma'am, are you there? Miss Bhumika Pandey. Okay. Next, Renuka Sheshrao Namawad.
Yes, I'm here.
Okay, go ahead, ma'am, with your paper.
Okay. Yes. The slide is visible to you, sir?
Not yet.
Hello. Is my slide is visible to you?
Not yet.
No.
No. Okay.
Now it is okay.
Yes, no.
Oh, okay. I'm sharing it again. No, I think it's not visible, right? Slide is not visible.
Ma'am, please share your screen.
Yeah. So I'm sharing it. Yeah, please check out. Is my screen is visible to you?
Now it is visible.
Maybe, yeah, due to the network issue, maybe it will be late visible. Okay. Now I'm starting it. May I, sir? Hello.
Yes, please.
Yeah, thank you. Good afternoon, everyone. I'm Renuka Namwad, a research scholar from the Department of Mathematics, Love Professional University, Punjab. It is my pleasure to present at the International Conference on Green Innovation in Chemistry, Physics, Mathematics, and Computer Science 2025, where I will be sharing my research article titled Exponential Backordering Inventory Model Addressing Shortages in the Finite Planning Horizon. Here we will the flow of the discussion will be, first of all, we will see the introduction, then the literature survey, then the mathematical modeling, then some result will be discussed here, and then finally the conclusions. So the focus of the study is about the investigating an exponential complete backordering model along with the partial inventory models. Then addressing the shortages considering price sensitive demand dynamics across planning horizons, and which aims to optimize the inventory control strategies by integrating exponential backordering principles. Then this is the diagram which explains the exponential complete backordering in the inventory system. When shops face a stock out, customer places the back order. Instead of canceling their demands, customer wait until the stock is replenished. Once the replenishment arrives and the stock comes in, all the back orders are completely fulfilled. This restores happy customers satisfactions, turning waiting customers into the happy customers, while the system maintains smooth operations. For this, we see some real life examples like the pharmaceutical industries where the shortages of essential medicines occur due to the production delays and price sensitivity, then pharmacies and hospitals usually face partial back orders. Some patients wait for the replenishment while others switch to the alternative. By applying the exponential complete back ordering model, suppliers can strategically plan replenishment and pricing to minimize the cost, ensure timely drug availability, and improve patient satisfaction. In this, the methodology which I have used to validate the model. I have given advanced numerical iterative method by which it is validated using the mathematical software, then the analyzing the total cost of the considering exponential backordering rates and the price sensitive demand, and I have worked in the finite planning horizon. So, moving to the literature review, as the literature review is the core part of the research, as Stephen in 2014 and David Simchi Levy in 2005 addressed the demand forecasting in inventory control along with the back ordering. Then Shen in 2019, Stephen in 2020, given the pricing strategies, demand elasticity, and inventory model which accommodate the demand elasticity. Then catch on in 2000 and How Lee in 1997 given a supply demand alignment inventory models for managing shortages and addressing demand variability. Then Arjun in 2020 and Kumar in 2020 given an inventory policies for perishable and price sensitive product with the dynamic demand. Then the notations which I have used in this, the H will denote the finite time horizon. Then the demand rate is denoted by the D, where the D is the parameter of price sensitive, where P denotes the price sensitivity, A minus BP. In this form, we will give the demand rate. Then the OR will denote the cost of the replenishment or purchasing per order. Then S is the denote the shortages cost per unit time. Then IG gives the total inventory carried out during the interval TJ and SJ. As this is the finite planning horizon, we have considered for the some time period interval in which TJ is the time period of the replenishment and SJ denote the time period of the replenishment in the shortage during the shortages, where Q denotes the total optimal order quantity during the planning horizon. Then IB is the instantaneous shortages during the shortage period, and theta is the inventory dependent parameter. Then moving toward the mathematical part, which is very important for the research, then the first initial equation of the inventory, which gives the differential equation, that is the differentiation of inventory with the change of demand, is given here in the interval tj to sj plus 1. Then on taking the on including all the parameters, and the first equation which is gives the economic order quantity for the replenishment, and the tr denote the total cost of the retailer. Then this is the equation of the total cost of the supplier. After differentiating with respect to the time tj, we get the minimum cost for the retailer, which given by this equation. Then the total cost of the retailer during the shortage period, which is a minimal cost, will be there. As we all know that the differentiation gives the minimization principle, which gives the minimum cost of the total cost. Then this is the Hazen's matrix we used for the total cost, which aims to the optimal replenishment period for a fixed replenishment cycle and to improve it, the unique solution to the nonlinear system represented. To do this, we analyze Heisenberg matrix to the total cost function, that is TC, which helps us determine whether the function is convex. The Hazen matrix is constructed from the second order derivative of the cost function with respect to the replenishment interval Ti and the number of cycles n. For the convexity, the Hazen matrix must have to be positive definite, which is the diagonal entries are positive and strictly diagonally dominance. Then okay, this is the numerical example which I have used, in which I have assigned the different parameter some values and solved it using the mathematical software and get some different cycles values for the where we can see the change of replenishment time when the person should be replenish the stock, which we have graphed in this using the Python, and this is the increasing value of the replenishment time in during the shortages. Then here we have introduced the table which includes the total cost of the retailer along with the total optimum quantity for the parameter A, where parameter A varies from 0.1 to 0.6, and we can see the different the changes in the total cost of the replenishment and the quantity order quantity. Then in this we can see the replenishment cycle, where in the first replenishment cycle for the value parameter value of 0.1, we can see that in the sixth cycle the optimum quantity can be assigned. Then for the second value of 0.2, we can see the optimum quantity of in the sixth cycle, and so similar. And here we have graphed some total cost of the retailer, total cost of the supplier, heat map using the heat map, which is the sensitivity analysis of the shows that the parameters C and alpha are highly influential, causing significant shift in total cost and order quantity, especially for the retailer, while parameter A and B have moderate to minimal effect. Graphical visualization is using the Python. Heat maps are drawn, illustrate the sensitivity of the retailer cost, supplier cost, and the optimal quantity. Optimal quantity graph is given here. This is the or total order quantity trends with the parameter using the heat map. Then the managerial implementation. The managers can reduce the cost, get the most from back ordering by keeping the right stock levels, using good demands forecasting, giving customers reward from waiting, and making fair deals with supplier. Checking back orders regularly help keen operations smooth, customers happy, and profit growing. And while about talking about the conclusion, this paper develops an exponential complete backordering inventory model to handle shortages in a finite horizon with price sensitive demand and linear trends, supported by Mathematica and Python. The model optimizes total cost, enhances supplier retailer coordination, and highlight the sensitivity of the cost to parameters C and alpha. It provides a practical tool for inventory managers to minimize stockouts, improve efficiency, and strengthen customer satisfaction with potential extensions to multi-echelon and stochastic demand settings. These are some references which I have used. Thank you for giving me a chance to present here.
Thank you, ma'am. Any questions for the participants? Okay, moving to the next presenter, Mr. D.S. Muske.
For disturbance, sir, with the permission of chair and co-chair, I would like to announce that Dr. Dixon Adams sir had joined from Ghana. Sir wish to greet us because he is having another important meeting, so he will leave after his greetings. So, with the permission of chair, respected chair and co-chair, shall I invite him, sir?
Please, ma'am.
Yeah. I request Dr. Dixon Adams, sir, from Kwame Nkrumah University Education and Innovation Center. Sir is the professor there at Ghana. Sir had joined with us. I request you, sir, to please speak a few words as a blessings and as a greetings to the all the gathering or whomever joined over here. Over to Dr. Dixon Adams, sir.
Hello, am I
Yes,
audible, please?
yes, sir. Greetings of the day, sir.
Yes, greetings to you all. I'm very much excited to be a part of this international conference. It's unfortunate that I couldn't join from the beginning due to several engagements here at the university, but I'm happy that finally I've been able to join. So I would like to especially thank the organizers of this international conference on green innovations in chemistry, physics, mathematics, and computer science. A special thanks to Dr. Prasad Kanzodi, and who is the Dr. Prasant Bukhari. I don't know if I've gotten the name right, the Vice Chancellor for Gondwana University. We stand in solidarity with you, Kwame Nkrumah University of Science and Technology in Ghana, and we are happy to partner with SIDV Foundation, a foundation that is doing very well in bringing academics together to share their academic findings, like their research findings in diverse fields. So a warm welcome to all of you, and thank you to the presenters. I really enjoyed your breathtaking findings from your research. So thank you so much and welcome, everyone.
Thank you so much, sir. I know how much busy you are, even though you had spared your valuable time for us and you had joined with us, sir. It means a lot for us. Thank you so much, sir. Thanks a lot. Dr. Sunanda, ma'am, are you there in the meeting? Sir had joined. Okay, ma'am may be busy in some other arrangements. Thank you so much, sir. Thanks a lot.
Thank you, sir.
Request Chair and Co-Chair, sir, please continue with the technical sessions.
Thank you, ma'am.
Hello.
So moving to the next presenter,
Thank you, sir.
Mr. D.S. Muske.
For joining us, Adams. Hello.
Yes, sir.
Hello. Thank you, sir, for joining us and for motivating participants.
Sir, there is multi-audio disturbance. Is anyone going to talk?
Good morning, sir. Good evening.
Okay. Shall I move to the presenters?
Aruna, ma'am.
Yes, sir. Yes, sir.
Sorry to interrupt you. Ma'am is joining us. Little bit address will be given.
आता वेळी start करतो. Ma'am, valedictory. We will start the valedictory. Hello.
Yes, please.
Thank you, Adam sir, for joining this conference. We will start valedictory in 5 minutes. Dickman sir, hai kya?
Yes, sir. Yes, ma'am. Dixon sir had joined. He had watched some of our presentations also, but he could not able to speak at the time. Now he had spoken and he had given his greetings to all of us.
Okay, Ankush sir.
Sir,
Proceed
shall
for
we
further.
declare this session over or proceed with the other presenters also?
Proceed with other participants.
Okay. So next presenter is Mr. D.S. Muske. Are you here? Okay. Next, Miss Pranali D. Bhaisare.
Yes, sir.
Are you
Yes,
here?
sir, I am here.
Okay. Proceed with your presentation.
Yes, sir. Good afternoon, everyone. Good afternoon, everyone. May I audible, sir?
Yes, you are audible.
Yes. Good afternoon, everyone. Respected chairperson and participant, my name is Pranali Bhaisare. I am CHB faculty member in Department of Mathematics at Rashtrapita Mahatma Gandhi College, Nagpur. I am grateful for the opportunity to present my research paper. Title is Relativity in GPS and Modern Navigation Systems, a review. Purpose of the study: the global positioning system has emerged as an indispensable tool for navigations, timing, and communications worldwide. The procedures of GPS depend upon accurate synchronizations of atomic clock aboard satellites with those on Earth. However, relativistic effect from both spatial and gravity and general relativity cause systematic deviations in satellite clock rates, leading to significant position error if incorrected. This study aimed to analyze the relativistic influences affecting GPS satellite clock and to highlight the corrections method that ensure the exceptional accuracy of the system. Method used in a system: the analysis examine the impact of spatial relativity, that is velocity based time dilation, general relativity, gravitational frequency shift, earth rotations, that is Sagnac effect, and orbit abnormality, periodic effect on GPS clock rates. Quantitative calculations are provided for the time dilation of site based on orbital velocity and gravitational potential differences. The study also reviewed corrections mechanisms implemented in the operational GPS, such as pre-launch frequency adjustment of satellite clock, ephemeris-based real-time update by the navigation's message, and a continuous ground control monitor. Result of the study: it is founded that spatial relativity slows satellite clock at approximately 7 microseconds per day due to orbit velocity, while general relativity accelerated them by about 46 microseconds per day because of the weaker gravitational field and orbit altitude. The net effect amount to a daily gain of 38.5 microsecond, which would corresponding to over 11 kilometer of the navigation error per day without corrections. Additional phenomena of such a significant effect contributed nanosecond level discrepancies corresponding to the meter scale error, while orbit eccentricity introduced the periodic variations that can further affect time precision. This implemented strategy of pre-launch frequency of sight minus 4.46 into 10 to the power 10 coupled with broadcast corrections parameter and ground segment monitor effectively mitigates these relativistic deviations. Implications. These research underscore the relativistic corrections are not a minor refinement but foundational requirement for GPS functionality. By systematically incorporate corrections for spatial and the general gravity, rotational effect and orbital instability, GPS achieve the sub-meter accuracy upon which the countless civil, scientific and military applications depend. These systems thus serve as a practical demonstrations of Einstein's theory and illustrate relativity role not only in the theoretical physics but also in the reliable operations of critical technology that underpin modern society. The conclusion is the function of GPS is a practical demonstrations of the Einstein's theory of relativity. Special relativity caused the satellite clock to tick slower by about 7 microseconds per day, while the general relativity make them tick faster by nearly the 46 microseconds per day. The net effect is a speed up of 38.5 microseconds per day, and which is, if incorrected, would lead to navigation's error of over 11 km per day. Additional relativistic influences such as the Sagnet effect, orbital eccentricity also introduce the measurable error, and to maintain the accuracy, GPS incorporate pre-launch frequency offset, continuous ground monitoring and the corrections algorithm transmit through navigation message. And these relativistic corrections are not a theoretical refinement but as a essential foundations ensure GPS remains a precise and a reliable global navigation system. Thank you. Thank you, sir.
Thank you, madam.
Thank you, ma'am. So I think we are there is last presenter, Mr. J. Madavi. Is he here?
Yes, sir. Yes, sir.
So please proceed with your paper presentation on graph theory and advanced loop towards chemical planes.
Okay. Shall we conclude, sir, this session?
Sir, last presentation रह गया ना अभी.
कौन सा?
Sir, we have last
presentation ने नाम दिया.
Hello.
Hello.
सर एक प्रेजेंटर बचा हुआ है.
कौन सा?
मडावी सर है.
हेलो सर.
प्रेजेंट है पार्टिसिपेंट लिस्ट में, उन्होंने रिस्पांस भी दिया. मडावी सर.
हेलो सर.
सर स्टार्ट योर प्रेजेंटेशन.
सर हेलो सर, मैं ऑडिबल सर. मतलब स्क्रीन इज शेयर.
You are audible. Please share your screen. Please share your PPT.
Screen is shared, sir. Hello. Whether screen is shared or not, sir. Hello.
Sir, it is not visible to us.
No.
Hello, sir. Hello, am I audible, sir? Screen is.
You are
Sir, you are
audible,
audible, but
but
your screen is not shared.
Sir, your audio is coming, but PPT is not showing.
Hello, screen is visible, sir.
no,
Hello, am I audible?
No,
sir,
sir.
screen not visible.
Sir, you can try re-injecting yourself into the meeting.
Sir. Hello.
Sir.
Yes, sir.
सर आप डिस्कनेक्ट होकर फिर से ज्वाइन कीजिए मीटिंग. Maybe you have a problem with your PPT presentation.
Hello.
Hello. It's visible, sir. Screen is shared.
No, your audio is coming, but your screen is not visible.
सर इनका PPT है ना अपने पास.
Sir. Hello.
Hello.
हाँ.
Your screen has not yet shared, sir.
Madam, now.
No.
No.
Oh.
Sir, what device you have connected with? Laptop or a mobile?
Mobile, sir. It's mobile, sir.
Sir, there is a button share.
Yes, sir.
Tap
Share.
on that and share what screen you have open in your mobile device.
But it's not opening, sir. So now,
Yes.
Now it came. Now it came and again gone.
Sir, please find a share button on your mobile.
Sir, your video is visible, but your presentation is not visible.
Pratap sir, you do one thing, you just share your PPT to me. I'll be presenting over here and you can explain there to avoid the this
Okay.
time.
Okay. Okay. Now only I share.
Actually, many guests are being waited.
Okay, Ankush sir, and
Sir.
yes, sir. We are running out of time, so we have to conclude here.
Yes, sir.
Okay. So, as of we come to the conclusion of this technical.
Sir, he had shared his
Mic
PPT to
mic
me.
on
Shall I present from here and he will explain? Is it okay, sir? Respected chair and co-chair.
एक minute, ma'am.
No issue, ma'am. You can
Yeah.
present from there.
Yeah, thank you. Thank you so much. And please allow me to share my screen.
I take this opportunity to sincerely thank you to our resource person, Dr. G.D. Kedar
Sorry, sir.
sir. Yes.
Please, wait for 5 minutes, sir. This last presentation, after this we can have.
Okay.
Just give me
Madhavi
2
sir maybe may have shared his presentation to the ma'am. She
Yes,
is
sir.
going to present and Madhavi sir is going to explain that presentation.
Pratap sir, are you ready, sir, for explaining?
Yes, madam. Yes, madam.
Yeah. Please let me know, sir, whether my screen is visible.
Oh, yeah.
Yes, ma'am.
Yes.
It is now visible.
Yes. Okay. So very good afternoon to all. So sorry for the interruption. So screen is not shared. See the topic is so respected chair, co-chair and organizers of ICGICPMCs 2025. See this I am presenting a graph theory and advanced technique or loom towards chemical claims. So in that the next part abstract. See this graph theory. So definitely what happens, it is a chemistry of graph. So therefore it is called as graph theory. And it was acknowledged both dynamic and also math. So mainly it concerns about physical and chemical properties and related with chemistry. So especially in this era, model of molecules and numerical data, so they are easily shared by using this graph theory. So just we are working on that, sir. But in the, so several, for that, we are going to use several topological indices. So mainly for the physical properties, for example, we can take the alkanes. So then, yes, madam. So here, the chemistry of the graph. So mainly it is a division of which facilitates mainly the physical properties. So now what is graph? So a graph, for example, if you are going to take G of V and E, V is vertices and so E is edge. So concerning to our chemistry, chemical bonds, so generally, so it is denoted as edges, and then the atoms or molecules, so they are denoted as vertices. But here, so therefore it is called as chemical graph. So in chemistry, the edges are, they are denoted as chemical bond, and then vertices are atoms. So therefore it is called as chemical graph. And here, when you are going to review that, so we come across plenty of molecules. So therefore it is, the chemical graph is also called as molecular graph. So for example, carbon, so it has 4 bonds and hydrogen 1 bond. So there we come across these edges, and there will be no evidence about the molecules. So where the hydrogens are eliminated. And moreover, next, the new graph, it is obtained by, for example, if you are going to take the alkanes, so here the conventional, it is also called as alkanes are always straight chain domain. So with all carbon atoms, so therefore they are also called as connected graph. So connection of carbon and carbon is there. So therefore, here we are not going to find any disconnected edges, but the connected graph, they are independent. A matching of graph, so it is possibly, it is done by using the formula. So that is, it is also called as simple matching polynomial. So that is sigma of k is equal to 0 to p by 2, a of k and omega p minus k. And here we are going to discuss about some of the topological indices that are mainly used in chemistry, mainly to find out the physical properties, geometrical structure of compounds. And so here, so what are these, the topological indices? Topological indices, so they are nothing but the invariant graphs, and they are mainly used, so they are mainly used to modify some graphs. So they are mainly used to modify some of these graphs. Next, madam. There are different topological indices. Relative molecular mass. Next slide. The relative molecular mass. So here, so what is this relative molecular mass? So it is nothing but mainly related with the total mass of a compound, and it is equal to the sum of all individual atomic masses. For example, if you are going to take the alkane, so n number of carbon atoms, so relative molecular mass, so mRn is equal to, so 12.0115 into n plus 1.00797 n plus 2, so it is given. And here, for example, if you are going to take 2,2-dimethyl butane, it is already 86.17. So with this, the topological indices, so we can also calculate boiling point, and also especially for this alkanes. So another thing that is Hoyosa index. So generally it is called as HI. So this Hoyosa index, Hosoya index, so it is given by Hosoya in the year 1982, and mainly discussed about the relationship between the boiling points and then molecular descriptor. Suppose 2,2-dimethyl butane, so it is omega to the power of 6 plus 3 omega to the power of 4 plus 5 omega to the power of 5. So therefore, finally, 1 plus 3 plus 5. So the Hosoya index of that, the 2,2-dimethyl butane is 9. Then Wiener index, next slide. So Wiener index, so it is Wi. So this Wiener index, so it is first mainly used to calculate the distance of all the pairs among the vertices. So it was first coined by Wiener. So therefore, it is called as Wiener index. See here, W is equal to half of sigma of I, sigma of J, Dij. For example, if you are going to take 2,2-dimethyl butane, so it is already we have the edges and also vertices 8 into 1 plus 8 into 2 plus 4 into 3 divided by 2. So it is 36 divided by 2, it is 18. So Wiener index for 2,2-dimethyl butane is 18. So next we consider another the topological index. So that is Randic index. So it was also given by the scientist by name Randic. So therefore, it is called as Randic index. So how here we are going to calculate? So especially this Randic index, it is mainly related to physical properties of alkanes. So here we are going to calculate, and one example they have given 3-ethyl, 2-methyl pentane. So 3 ethyl groups are there, 2 methyl and 1 pentane. So pentane 5 carbons. So therefore, so here 2 into 1 by root 3 plus 1 1 by 3 plus 2 into 1 by root 6 plus 2 into 1 by root 2. So they are calculated and given 3.7. So next one is Bulban index. So next slide. So here the name itself indicates the Bulban index in 1982. It was given by Bulban and it is acceptable. So mainly for isomers. So Bulban, it is mainly regarded for the isomer for isomers. So isomers, iso means same. They are having same molecular formula but different structures. Here it is concerned with the only isomers. And Bulban index, so it is called highly discriminating distance-based topological index. And again, it is one of the tool for advanced chemical graph theory. We can calculate the boiling points. So we can calculate. So next one is Harare index. So it was given by Harare in the year 1991. So mainly why it is called as Harare means on his 70th birthday, he noted that Harare index and given that concept. So that too in his 70th year. So this Harare index, so it is mainly related to the individual molecules, so which are having or which are related to the pairs. So we are going to find a plenty of pair of compounds. So it is mainly related to the Harare index. So finally, conclusion. Lastly, see mainly it is these topological indices. So they are mainly related with chemistry and also mathematics. And here the property of molecules, so we can study here. So therefore graph theory is categorized as a creative claim of math with chemistry. So chemistry and the graph theory, they are nothing but the two faces of the coin. So one cannot work without another. So therefore, so here chemists are also playing a vital role in this graph theory, especially the advancement of the molecules. So it is an additional tool. So it is called as an additional tool. So some of the references I have quoted. So these are some references.
Thank you, sir. So
Thank you,
we
sir.
are done
Thank you
with
very much.
all the presentations in this technical sessions. So thank you all the participants who have attended this technical session. I also thank Dr. Sisodia sir for his active attendance. Over to you, Dore sir. You can proceed for further sessions.
Okay, thank you, sir. As of now, we are coming to the closing session of technical session. Special thanks to Dr. Dilip Soni sir and Renuka Namwar madam for a very nice presentation. I take this opportunity to sincerely thank to our response person, Dr. G.D. Gida sir, for their excellent invited talk on on mathematical modeling in heat conduction. It's nice to hear from him. Next, I am also thankful to our session chairperson, Dr. Ramnaresh Sisodia sir, and co-chairperson, Mr. Ankush Ramtege sir, for their valuable guidance. I also extend gratitude to all the presenters for their remarkable contributions and to the audience for their active participation. We now move ahead to the next session, validatory session of the conference, which will be start soon within 5 minutes. Kindly stay connected. Thank you. Thank you all participants.
Thank you, sir. Before starting this validatory function, and you said that within 5 minutes it is about to start. So that in these 5 minutes, I wish to give some announcements regarding the post-conference works. We are about to send all the presenters certificates very soon. Most probably, I hope by tomorrow evening, we'll share all the presented certificates to their respected registered emails accordingly to the IDs, presentation IDs given in the program schedule. Already we are on the way to prepare all the certificates. And afterwards, next post-conference work is conference proceedings. So already we got ISBN number for the conference proceedings, and we had prepared the cover page also. And we are on the way to make all the abstracts in one book, that is as in the form of an conference proceedings with an ISBN. And that is also very soon we will give the first proof in our group, and we'll wait for some corrections. And afterwards, after incorporation, all the corrections in that, we'll give the second proof. And after second proof approved by all the people and the college side, we'll go for the publication of that conference proceedings. This is first documentation. And second documentation, those who are wishing to publish your articles in our international journal, that has already announced and that had been given in the brochure also. International Journal of Science, Engineering, Arts and Management, which is a double peer reviewed journal. We are about to publish all your articles in that journal also, but it will take some time. And I request after step by step, one by one, we are able to do all these things. So first step is we are on the way to send all the presentation and participation certificates. And second step, we'll go for the ISBN book conference proceedings. Afterwards, we'll announce in the group for sending your articles in a proper format. And I request all the presenters who wish to publish your papers in our journal to please be stipulate to the format which we had given, because I had observed myself many lapses in the abstracts which have been sent to us. Actually, strictly they have to be rejected, but we should not discourage any of the participants. That's why I wish to share some of my views here, that whatever the instructions given in the brochure, we must follow compulsorily. Somebody they had not given their affiliations, somebody they had not given their even title of the abstracts. So like, please rectify all these things once after sending this first proof of our conference proceedings. So all these things will be happen slowly and gradually within a stipulated time, and I'm trying to give it in a very short span of time. So I request all the presenters and participants and respected guests to please give us some time to do all these post-conference works. Thanking you for giving me such a wonderful opportunity to announce the post-conference things which are going to be done by ICGI Foundation. Thank you so much. And before starting this valedictory function, I request any one of the participant side other than the college people and ICGI Foundation to please give away your feedback for 1 or 2 minutes. Any of the suggestions or any incorporations still we need to do, any modifications we need to do, please advise us. Other than the college people and ICGI Foundation people, whomever present over here, please speak away for 1 or 2 minutes.
Hello, ma'am.
Yes, sir.
Madam, I'm myself Prashant Mendarka from Nagpur University. I presented my presentation in the morning session. So I would like to congratulate ICGI Foundation and the Gram Gita College for the successful conduction of this international conference. Conference was overall overall covered very diverse and very relevant topics for the modern days. All the presenters and all the keynote speakers were very knowledgeable and quite engaging, I would say. Event was well organized by the ICGI Foundation and the Shimoor College. This conference provided us with the networking opportunities among our communities among our research communities, and the overall impact of this conference will be quite positive. I would like to congratulate once again to Siddhi Foundation and the Shimur College, Gram Gita College, Shimur. Thank you, ma'am.
Thank you, sir. Thank you so much, sir. Thank you for your valuable and kind words towards the conference organizing team. Thank you so much.
Thank you, ma'am.
I wish to hear something from Dilip, sir. Dilip Soni, sir.
Hello. Hello, am I audible, ma'am?
Yes, sir. Yes, sir.
I want to congratulate all the participants who have presented their papers and particularly the SIDBI Foundation and this Gram Gita College, Timur. I want to thank all the participants, all the organizers, and all the technical session heads that they have given the chance to participate and present their papers. Thank you all, everyone. Thank you.
Thank you, sir. Thank you, Dilip, sir. Thank you so much. And now
Thank
I
you, ma'am.
post Nagesh, sir, to please announce for the valedictory function, sir.
Hello. Hello. Good afternoon, everyone.
I request
Hello.
spotlight on the stage.
Good afternoon, everyone. Please welcome today's guest of valedictory function. I request everyone to please give them huge round of applause. I humbly request all the dignitaries to kindly offer a garland to the portrait of Rashtrasanta Tukaji Maharaj. Thank you, everyone. I request all the dignitaries of today's function to take their seats. Thank you, everyone. Good afternoon, respected guests, esteemed speakers, delegates, and participants. I am Pratna Kudragade, and it's my pleasure to welcome you all to the valedictory function of the International Conference on Green Innovation in Chemistry, Physics, Mathematics, and Computer Science, organized by Gram Gita Mahavidyalaya Chimur in collaboration with SIDBI Foundation, Visakhapatnam, Andhra Pradesh. During the past two days, we have experienced a series of enlightening sessions where scholars and researchers from different fields have shared their innovative ideas and research. This conference has been hub of knowledge, inspiring discussions and insightful presentations. Today, as we conclude this remarkable journey, we come together to acknowledge and celebrate the efforts of our speakers, participants, and organizers who made this conference good success. Now let's move to welcome ceremony for the guests. On this today's occasion of the validation of the international conference, it brings honor and joy to warmly welcome our esteemed special chief guest, Honorable Dr. Sriram Thavdesar, Vice Chancellor of Gondwana University, Portugal. On the behalf of organizing team, welcome you, sir. Also, chief guest of today's function, Honorable Dr. L.S. Ladke, sir, Nilkantrao Shinde Mahavidyalaya, virtually welcome, sir. Also on the dais, we have with us our conference director, president of the today's evening, principal of our college, Dr. Sunanda Aswale, ma'am. I welcome you, ma'am. Also, we have Dr. Umeshwar Anand, sir, convener of this international conference. Welcome, sir. Also, we have Dr. Nilesh Thakkar, sir, IQSC coordinator of our college. Welcome, sir. Also, we have Varita Kati, ma'am, conference organizing secretary. Welcome, ma'am. Dr. Dixon, sir, Dixon Adam, sir, who joined with us virtually. I welcome you, sir. Over the last 2 days, we have insightful sessions, inspiring talks, and excellent presentations that made this conference a great success. To give a brief summary of the entire event, now I request Dr. Varita Kati, ma'am, to kindly present the conference.
Thank you, Pratna madam. An international conference on green innovation in chemistry, physics, mathematics, and computer science, organized by Siddhi Foundation
madam.
with Semana Vidya Vandikas Prashikshan Mandal, Gram Gita Mahavidyalay, Chimur, on September 29-30, 2025. The conference brought together researchers, academics, and students from diverse fields to share and discuss recent developments, innovations, and challenges in chemistry, physics, mathematics, and computer science. The main objective of the conference were to provide a platform for knowledge exchange and collaboration among the international experts and young researchers, to promote interdisciplinary research by exploring 4 core disciplines and to encourage networking opportunities for future collaboration. The conference began with the inaugural ceremony, which includes a traditional lamp lighting ceremony by the dignitaries to symbolize knowledge and wisdom. The principal of the college, Dr. Sunanda Aswale, ma'am, welcomed the distinguished guests and participants and highlighted the conference significance. The inaugural speech was given by Dr. Prashad Kokare, sir, Vice Chancellor at Gondwana University, Gadchiroli. Honorable guest from Siddhi Foundation, Dr. Rania Lampo, Greek Ministry of Education, Greece, addresses the conference and convey her best compliment for our institute. Dr. Dixon Adam, educationalist, innovation in science and technology, University of Sciences and Technology, Ghana, also joined the session and addressed and encouraged the participants. Mr. Nagababu Abbaraju, Director VECO Labs, Private Limited, Hyderabad, President SSRD Siddhi Foundation, have also joined the session to encourage the participants. Dr. Prasad Khandode sir joined the session as a special guest and presidential speech given by Ms. Roshnitai Vadettiwar. Keynote speech was delivered by Dr. N.G. Belsare, ex-principal Brijlal Biyani Mahavidyalaya, Amravati, who also speak on important landmark in the human journey of scientific thinking and development with special reference to Einstein. The two-day conference featured a variety of technical sessions, including invited talk, oral presentation organized for each discipline. In the first technical session, chemistry track, an invited talk on the topic green methods for the synthesis of fluorinated and other heterocycles was given by Dr. Prashant Borkar sir, Assistant Professor, Department of Chemistry, JB Science College, Varda. The session was chaired by Dr. Prashant Thakre sir with Atul Nagpure sir. Oral presentations showcased the research on the topics such as green chemistry, environmental chemistry, coordination chemistry, and material chemistry. In technical session 2, computer science track, presentation were held on the topics like advanced computing and intelligent network. This session was chaired by Dr. Krishna Karu sir with Aslam Surya sir. On day 2 of the conference, in technical session 3, physics track, a keynote talk on the topic lanthanide dope-up conversion, phosphor for the fingerprint detection and security application was delivered by Dr. Vijay Pavde sir, LIT Nagpur. Technical presentation covered optoelectronics and advancement in both experimental and theoretical physics. The session was chaired by Dr. Atul Yerkude sir with Amol Nande sir. In session 4 of the conference in mathematical track, key talk was focused on the topic mathematical modeling in heat conduction, was delivered by Dr. Ganesh D. Kedari sir, RTM Nagpur University. Session covered areas like mathematical modeling and latest development in pure and applied mathematics. This session was chaired by Dr. Ram Naresh Sisodia along with Mr. Ankush Rampeke. Attendees gained insight into the latest research findings and emerging trends across the 4 scientific disciplines. This conference fostered an appreciation of interdisciplinary work and facilitate new connection between researchers. The conference provided a valuable learning experience for students who were exposed to cutting-edge research and given opportunities to present their work. The two-day international conference was a resounding success, achieving its goal of knowledge exchange. The high quality of presentation and active participation of attendees highlighted the vibrant state of research in chemistry, physics, mathematics, and computer science. The organizers, satisfied about the idea of collaboration sparked by this event, will lead to significant advancement in respective field and beyond. Thank you, all of you. Thank you all.
Thank you so much, ma'am, for summarizing the proceedings so beautifully. I also welcome Samir Belave sir, co-convener of this international conference. Welcome, sir. Now I introduce chief guest of today's function. It's my pleasure to introduce today's chief guest, Honorable Dr. L.S. Ladke sir, Principal of Nilkantrao Shinde Mahavidyalaya, Bhadravati. He has more than 38 years of experience in the teaching as well as administrative experience. Sir has involved various university committees, curriculum designs, research guidance, and academic development. Sir published more than 35 national and international papers. Sir has guided 7 PhD students, out of which 4 have been awarded the doctorate degree. He was honored many awards like Rashtriya Vikas Ratna Award and Gunjan Gaurav Award. He is chairman, Board of Studies in Mathematics and Senate member in Gondwana University and many more achievements. Now I respectfully invite Dr. L.S. Ladke sir to kindly address the gathering with valuable word. Dr. L.S. Ladke sir.
हाँ मैम.
हा हॅलो सर, आवाज येत आहे इकडे. तुम्ही कंटिन्यू करू शकता.
Hello. Hello.
मॅडम सरांचा आवाज येते का?
Am I audible?
नाही, तुमचा आवाज नाही येत.
Yes, sir. Yes.
हा.
Am I audible?
Yes, माझ्या ह्याच्यावर.
Hello.
Sir, you are clearly audible.
I am audible.
Yes, sir.
Okay. हाँ. Hello. Very good afternoon to you all. Honorable Chairperson of this validatory function and Director of this international conference and Principal of Gram Gita Mahavidyalay, Chimur, Honorable Dr. Sunanda S. Aswale Madam, a special chief guest, Honorable Pro Vice Chancellor of Gondwana University, Gadchiroli, Dr. Sriram Kavade sir, Patron of this institution, Sri Vijay Wadattiwar, MLA, Brahmapuri Savli Vidhan Sabha Kshetra, and So Kiran Wadattiwar and Miss Rohini Wadattiwar. Galaxy of these intellectuals, distinguished invited guests, faculty members, organizing committee members, students, and all the participants from different prestigious colleges and universities all over the globe. Ladies and gentlemen, at this moment, we are here for validatory function of 2 days international conference on green innovations in chemistry, physics, mathematics, and computer science. Organized by Siddhavi Society for Research and Development, a division of Siddhavi Foundation and Gram Gita Mahavidyalay, Chimur. The objective of this conference was to bring together researchers, academicians, industry experts, and students to share their views, research result, and innovative ideas in the field of science and technology with a special focus on sustainable and eco-friendly practices and to foster interdisciplinary collaborations for solving global environmental challenges through scientific advancement. It is our honor itself to honor this beautiful audience who gathered here to the validatory session of 2 days international conference. Needless to say, the organizer, Gram Gita Mahavidyalay Chimur and Siddhavi Society for Research and Development, a division of Siddhavi Foundation, made extraordinary efforts for the success of this international conference. I extend a warm hearted welcome to all of them, and special thanks to Principal Dr. Sunanda Aswale Madam for organizing such nice and successful conference. The time has come to draw a certain curtain to our program as we come to the close of it with complete participation of the scholars and research persons. I hope the deliberations, exchange, and provocative discussion have enriched the mind that can make use of the training for their future implementation in respective fields. I am quite convinced that these 2 days you have been able to share and learn useful skill, knowledge, and explore the ideas of the subject chemistry, physics, mathematics, and computer science for the benefit of your respective interest. I wish, therefore, to congratulate each and every one of you. Finally, I warmly welcome to you again, and my thanks to organizing committee for giving me opportunity to become a part of this validated function. Thank you. Jai Hind. Thank you, ma'am. Hello.
Thank you very much, sir, for your inspiring and valuable word. Thank you, sir. Now I introduce special chief guest of today's function. It's my pleasure to introduce Honorable Dr. Sriram Kavade, sir. Sir, currently the Pro Vice Chancellor of Gondwana University, Gadchuri, since Jan 22. Sir has experience as a Dean in the Faculty of Humanities in Gondwana University, Gadchuri. Sir has more than 40-year experience in the field of education. Sir has experience as a principal and professor in Sri Govind Prabhu College, Tadodi. Sir has been board studies and management councils and many other member bodies. Sir has published more than 15 books, 30 national and international papers, articles, and patent in his credits. Sir has guided 15 PhD students, out of which 9 have been awarded in their doctorate degree. Sir has received many prestigious awards, like members and several esteemed organizations. Due to technical issue, Honorable Pro-Chancellor Sir could not join with us, but he conveyed his message.
आता माझ्या इथे सुरू झालं.
Sir, IQSC
माझ्या इथे फोन आला, फोन प्रॉब्लेम झाला.
Read the message conveyed by you.
Hello. Good afternoon to all. Our Pro Vice Chancellor, Dr. Sriram Kavade, has unable to join due to some technical issue. On behalf of Dr. Sriram Kavade, I, Dr. Nilesh Thaukar, express his thought. A very good afternoon to all esteemed colleagues, participant, principal of various affiliated college, and all the teachers, researchers who are connected virtually for this crucial international conference. I consider it a profound privilege to deliver the valedictory address at this important and remarkably timely event. I am sincerely grateful to the President, Chairman, and Principal of Gram Gita Mahavidyalaya Chimur for inviting me to this platform. We are here today at the conclusion of the International Conference on Green Innovation in Chemistry, Physics, Mathematics, and Computer Science, jointly organized by SIDBI Foundation Visakhapatnam and Gram Gita Mahavidyalaya Chimur. The theme itself is a clear recognition that we stand at crucial stage. The global landscape is rapidly changing and our future depends on how well we prepare to meet the emerging challenges in green innovations for sustainable development. The most profound challenges to green innovation and conservation, from climate change to resource scarcity have a devastating impact on every vital sphere of human development. Our economy, education, health, and most acutely the livelihood of poor communities. To truly stand and resolve these complex issues, we need a multidisciplinary approach. This conference, by bringing together chemistry, physics, mathematics, and computer science, has strongly demonstrated a multidisciplinary approach. Chemistry provides the foundation of new, cleaner materials and sustainable reactions processes. Physics offer insight into energy efficiency and revolutionary renewable technologies. Mathematics prepare us with the models and analytics necessary for predicting environmental changes and optimizing resource use. Computer science delivers the innovative tools from AI-driven efficiency to big data analysis to scale up and manage global green solutions. I particularly commend the organizers for highly comprehensive selection of the topics for deliberation and technical sessions. Crucially, the conference effectively attempted to focus on sustainable innovative solutions that deliberately balance the three inseparable dimensions of true sustainable development. The economic growth ensures solutions are financially viable and create new green economics. Social inclusion guaranteeing that benefit of innovation reach all segments of society, especially most vulnerable. Environmental protection safeguarding our planet for current and future generations. With their vast knowledge, the presentation made by internationally reputed scholars have certainly helped us all the deeply understand the intricate issues connecting green innovation and sustainable development. I am confident that this conference had made a major contribution in not just recognizing but actively enhancing the relevance and urgency of multidisciplinary innovation for sustainable future. Quality education is truly the soul of human development. By addressing providing scientific thought on green innovation issue with both local relevance and global impact. The Gramgita Mahavidyalaya Chimur and the Sidvi Foundation Vishakhapatnam Andhra Pradesh have commendably fulfilled one of the prime responsibilities of a higher education institution. Congratulations once again on organizing such significant conference. I once again thank the organizers for the opportunity to address you today on such an important topic of global relevance. I wish you all the very best and great success for all your future endeavors. Jai Hind, Jai Maharashtra. Thank you.
We sincerely thank you, sir, for valuable guidance and support. Now, I kindly invite our delegates and participants to share your valuable feedback about conference. Your thoughts and suggestions will help us to improve and make future events even better. I humbly request Mr. Prashant Bedekar sir from Bhaubhuti Mahavidyalaya, Amgaon to present your feedback and share your experience with everyone. May I now request Mr. Ankush Ramtike sir, Gnanish Vidyalaya Navargaon, to give your feedback and share your experience with all of us. May I now request Dr. Sumit Vaure sir to give your feedback and share your experience with us.
Good afternoon to one and all. I am Dr. Sumit Vaure, Assistant Professor, Department of Zoology, Gram Gita Mahavidyalaya, Chimur. Today's valedictory function President, our respected Principal, Madam Dr. Sunanda Asmode. Guest on the dais, Dr. Anand sir, Dr. Thaukar sir, Dr. Belave sir, Dr. Khatti madam. In front of me, my all teaching and non-teaching staff. Today I am here to give feedback on this last day of this international conference. Whenever we organize any kind of international conference, there must be the participation of individuals is necessary. So far as my mind is concerned, I saw that most of the participants, they present very well. They present their papers, they present their various kinds of subjects, matters, which are very informative, very significant, and those who are newcomers, means research scholars, for them and all the teachers, they were very much, what we can say, for their research purpose is concerned, it was very, very significant, because whenever we attend any kind of international conference, we have very well guests with us in yesterday's and today's also. So I convey the message to all who have joined this international conference that this conference is successful, and I request all the participants that maximum papers should they have to publish in this conference, not for only API, PBS or CAS, but also for their research development is concerned. So thank you very much for all the organizing committee. Thank you. Thank you so much.
Thank you so much, sir, for your valuable feedback. Now it's my privilege to invite Dr. Sunanda Asmale ma'am, Principal of Gram Gita Mahavidyalaya, Chimur, to deliver the presidential speech.
राष्ट्रसंत तुकडोजी महाराज, special guest of the valedictory function, Honorable Dr. Sri Ram Kaure sir, Pro Vice Chancellor of the Budwana University, Chief Guest Dr. Raj Ladke sir, Principal of the Nekantrao Shinde Mahavidyalaya, Bhadravati, Dr. Dr. Aruna Ma'am, Founder and Director of the ICGICPMCs Foundation, all esteemed guests, dignitaries, delegates, researchers, and scholars. As we know, the conference is coming to end in the next few minutes. I am filled with the sense of pride, gratitude, and accomplishment. We have witnessed a rich exchange of the ideas and a celebration of the innovation and excellence. I would like to extend my heartfelt thanks to each and everyone for participation and engagement and contribution to this conference. Your presence has enriched our discussion, debates, and networking opportunities. I would like to thank Honorable Pro Vice Chancellor of Gondwana University, Dr. Kavre sir, for gracing the occasion with their esteemed presence. He conveyed his message due to technical problems. I would like to thank Dr. Ladke sir. In spite of his busy schedule, he joined yesterday and today also. I thank you very much, sir. To our keynote speakers, invited speakers, session chairman, and co-chairman, and also presenter, I offer my sincere appreciation for sharing your expertise, insight, and experiences with us. Your contribution have been valuable, and we are grateful for your time and efforts which you have given. I also thank Dickman sir from Ghana for contribution of constant support and his presence in conference. And thank you, sir. Now I would like my heartfelt gratitude to Aruna ma'am and her team for constant support. I thank you for hosting us and providing the opportunity for joint organization of this conference. I also appreciate her patience. As we discuss after the end of this conference, I urge you to carry the spirit of creativity and critical thinking. Let's unite to build connection, conversation, and commitment we have met here. Once again, thank you all for a part of this conference. Thank you. Thank you.
Thank you so much for your valuable address and inspiring words. Now to express our sincere gratitude, I kindly request Mr. Samir Melawat to deliver the vote of praise.
Thank you, madam. It is my proud privilege to propose vote of thanks on the behalf of the organizing committee of the International Conference on Green Innovation in Chemistry, Physics, Mathematics, Computer Science, jointly organized by Gram Gita Mahavidyalaya and SIDBI Foundation. First and foremost, I extend our deepest gratitude to our esteemed teacher of valedictory session. We are honored by the gracious presence of our special guest, Dr. Sriram Kaude, Pro Vice Chancellor, Gondwana University, and our chief guest, Dr. Lemraj S. Ladke sir, Principal Nilkantrao Shinde College, Bhadravati, for inspiring us with their words of encouragement and wisdom. I also express heartful thanks to inaugurator of conference, Dr. Prashant Bokare sir, Vice Chancellor of Gondwana University, Gadchiroli, and keynote speaker, Dr. Belsare sir, for their valuable talk. I sincerely thankful to Dr. Dixon Eden, Education Innovation in Science and Technology from Ghana, for addressing regarding this conference. I express heartfelt thanks to Mr. Nagab Adu Abraju, Director VECO Labs, and Dr. Rania Lampa Greek Ministry of Education for joining and addressing this valuable talk in this conference. I sincerely thank to our respected President Ms. Roshnit Tai Vijay Wadetiwar, President Semana Vidya व वन विकास प्रशिक्षण मंडळ गडचिरोली. Joining this conference, I also express my deepest thanks to Dr. Sunanda S. Asole Madam, Principal Gramgita Mahavidyalaya Chimur, whose leadership and constant guidance made this conference a great success. I heartful thanks to our invited speaker, Dr. Vijay Paude sir, Dr. Prashant Borkar sir, resource person, keynote lecturer from India and abroad, who share their valuable insight and cutting-edge research across the diverse domain. Your contribution have enriched the academic value of this event. I wish to express our gratitude to the collaborating institutions, CDV Foundation, Society for Research and Development, and publishing partner for their invaluable support. Our special sincere thanks to our session chairperson, co-chairperson, and paper presenter for maintaining the academic rigor of the session for contributing meaningful discussion. I express special appreciation to organizing team, faculty member, convener of this program, international conference, research scholar, non-teaching staff, and student volunteer of Gramgita Mahavidyalaya Chimur, whose tireless efforts behind the scenes ensured the smooth conduct of this two-day international conference. To all the participants from across the globe, we grateful for your enthusiastic presence and active engagement, which made this conference truly interactive and memorable. Finally, I thank to all who joined as a virtually as well as offline mode and making this event resounding success. On this note, we conclude this conference with renewed spirit of collaboration and innovation. Let us carry forward the knowledge shared here and continue to contribute toward the sustainable and green future. Finally, as we conclude this memorable conference, I once again extend my grateful gratitude to all dignitaries, speakers, delegates, and participants for their valuable presence and contribution. Now, let us all rise for national anthem to mark respectful conclusion of today's program for national anthem. Please stand up. एक साथ राष्ट्रगीत शुरू करेंगे, शुरू कर जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उच्चल बंग विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंग तव शुभ नामे जागे तव शुभ आशीष मागे गाये तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे भारत माता की भारत माता की thank you all.
Nagesh sir and Sunanda ma'am, shall I conclude this officially?
वीडियो नहीं दिसत होता.
Nagesh sir, please announce any of your college people that officially this meeting has been concluded. Ma'am. I request Nagesh sir.
Yes, ma'am. Yes.
Any one of the college persons, please announce that this meeting has been officially concluded, so that we can end of the meeting, sir. Okay, I myself, Dr. Aruna, CEO Sidvi Foundation, here with announcing that this meeting has been officially ended. Now I am ending this meeting. Thank you so much, one and all. And let us see in future also. Let us united in future also. Thank you so much, one and all.
Thank you, ma'am. Thank you for collaborating with us. And all the participants can leave now. And we are concluding here our validatory session. Please fill the feedback forms, which will be distributed on WhatsApp group. Thank you.
टाकते आता ते ग्रुपवर व्हॉट्सअपवर टाकते फीडबॅक